So you're looking to learn TypeScript. Good call. Imagine building JavaScript applications with confidence, catching errors before they happen, writing scalable code, and enjoying the benefits of strong type safety. Now, if you're watching this video, I can only assume that I don't need to tell you why you should learn TypeScript, but I will tell you why this is the perfect place to start. In this crash course, Jayson Lennon will guide you through the fundamentals of TypeScript. We're talking about the core concepts that will give you a solid foundation for building robust and scalable applications. Now, why Jayson? Because Jayson is a pro at breaking down complex topics into digestible lessons. He's been in your shoes before, learning from scratch and navigating the self-taught journey, and eventually becoming a seasoned developer. That means he knows how to make TypeScript click. By the way, Jayson also teaches a full TypeScript Bootcamp that goes way beyond the fundamentals covered in this course. If you want to check that out, you can grab the link in the description down below or click the link in the top right-hand corner. One more thing, if you enjoyed this crash course, please do me a favor and drop it a like and leave a comment with your questions, thoughts, or feedback down below. Alright, that's it from me, and let me hand it over to Jayson so you can start learning TypeScript. Enjoy!
In this video, I'm going to try and answer the question, why should you learn TypeScript when we already have JavaScript? In order to properly understand the benefits of TypeScript, we need to first take a look at JavaScript. If you aren't familiar with JavaScript, then don't worry. You don't need to know any JavaScript code to follow along. Alright, so we have this function called popup, which will show a pop-up to the user. The pop-up has a customizable message and has some options. So far so good? Well, not quite. We've already ran into a problem with this function, and it's the first line of code. So what is a message anyway? We can probably assume that it's some text data because that would make sense if we're going to show a pop-up. What about this options here? That could be anything. How do we set the options? What options are available? What happens if we don't set any options? What if we set too many options? We just don't really know. We don't have any information at all about this function other than it's called pop-up and has a message and option as parameters. So in order to use it, we'll either need to read the code for the function or hope that somebody wrote documentation for it. And that is up to date, of course. Just for fun, we're going to fully expand the code for the pop-up function. I know it's too small to read, and that's fine, because we're not going to be reading all the code. We only need to look at these 4 lines right here. So these 4 lines set up the default options. If we try using the functions without any options, then we'll get these defaults. This is useful information because now we know the available options, sort of. We know there is a kind option, and we know that the default is info. This is probably what kind of pop-up we can display. Since we can make informational pop-ups, maybe we can make error pop-ups or warning pop-ups too. We don't know though because there actually isn't any documentation for this example function. So we would need to read the code further to figure out if there are other kinds of pop-ups and how to use them. We also have this timeout function here, which likely means how long the message is displayed on screen. The number is 5,000, which seems like a lot. Are those in minutes, seconds, milliseconds? They're probably going to be in milliseconds because 5,000 seconds is over an hour. If we are just using this function, then this is sort of okay. In this imaginary scenario, we don't really need anything besides informational pop-ups, so we don't need to dive further into the code. It's safe to assume that the timeout is in milliseconds, so we can change that to another value if we wanted. This is fine as a consumer of the function. We'll actually be able to use this code and probably get an informational pop-up to work. But what if we were the person who actually had to write and maintain this function? If we were the ones writing this function, then we would set our defaults here in the beginning, marked in blue. And then we would write the functionality to make the pop-ups here in red. This makes sense because once we have the options set, we can make the pop-up. Except this part in red doesn't actually make the pop-up. Remember how we weren't exactly sure what kinds of pop-ups were available, and we didn't know if 5,000 was in minutes or milliseconds? Well, there needs to be code to check that, and that's what these lines marked with red are doing. So we have our 5 lines to set the defaults, which is fine because we want to be able to use this function with defaults. And then we have 23 lines to check everything else. This is called boilerplate code. It helps us get where we need to go, but it doesn't actually do the thing we're trying to do, which is to just make a pop-up. This little tiny part at the bottom is where our code to make the pop-up is actually supposed to go. There's nothing here yet. Let's continue. We should also write some tests to make sure that our function properly rejects broken options and invalid messages. Here on the right, we have 6 tests. These are used to make sure that the function accepts the arguments correctly. For example, the tests will check to make sure that the function works as expected if we give it a negative timeout duration, or if we don't give a message, or if we try to make an unsupported kind of pop-up. I programmed this function to produce an error in all of these situations. If we add up the code marked in red, then we get 59 lines of code. Remember, we haven't written any functionality yet to actually make a pop-up, and we already have 23 lines of boilerplate code and 6 test cases. There is no functional code here, and there are 0 tests to make sure that the pop-up actually works. The test cases are here just to make sure we can actually call this function properly. So we have 5 lines of usable code and 59 lines of code that don't actually do any pop-up related things. This code is also only useful for this one function, so none of these 59 lines contribute to any other part of the code base. So that's the situation writing JavaScript code. What about TypeScript? Here's the same function. We still have our 5 lines to set default values, but we reduced all the boilerplate in this function down to 0 lines. You'll notice here we do have a few extra things on the function line. We set this message to be a string, and that could be any regular text. In this options here, we take a look at our JavaScript version. Our pop-up options just indicates options, but our TypeScript version has options and this pop-up options text right there. We'll be taking a look at that shortly. The defaults here indicate that we are using some kind of pop-up options, and again, it lists out the kinds. One interesting note about the TypeScript version is we know that this 5000 is in milliseconds because it says so right there. So already just looking at a few lines of code, we can see much clearer how we're supposed to use this function, and all the documentation is just right here. It tells us what's going on. Here is the complete code listing in TypeScript. This is almost identical to the JavaScript code. It still checks to make sure that the pop-up has all the correct options, and it still makes sure that the millisecond timeout is correct as well. Remember how I mentioned that the JavaScript version would produce an error if anything was wrong? It's actually not possible to make the TypeScript version produce an error. That's the only functional difference between the TypeScript code and the JavaScript code. So the TypeScript code still has all the same checks as the JavaScript version, takes less code, requires fewer tests, and some of the code that's marked here in green is actually reusable across the rest of the code base. Here's a quick comparison of the numbers. Overall, TypeScript used 38% less code in this particular example. There's also another huge advantage that TypeScript has over JavaScript. Since the information needed to call the pop-up was encoded into the type system, we get live suggestions in our code editor as we type our code. Here are just a few examples of the pop-ups that you may see when working with the sample from the previous slides. We can get the number of fields that are allowed to be part of the pop-up options. We can get a listing of all possible kinds of pop-ups that we're able to create. And we get a listing of all the data that's required to actually call the function. All of this makes development much quicker and easier since you don't have to guess what data you need when working with the function. It all just pops up right as you type code. Your code will also be significantly more reliable since all of this is being checked automatically every time you hit a key. So if writing less code and having it work with a higher level of reliability sounds like something you could benefit from, you're in the right place. In this video, I want to go over how the course is structured so you can get the most out of it. First, we have demos. Demonstrations make up the majority of the course and will show how various things work in TypeScript in an isolated manner. The source files provided with the course have a demo file for each demonstration where you can write your code, take notes, and run and test your code to make sure it works. Having a structure like this allows you to add your own code and your own notes now and in the future, as well as test out new ideas related to each topic. It acts as your own personal executable database of information about TypeScript that you can build up over time and reference later. Next up, we have exercises. Exercises provide a way to get additional practice on a topic. They have a prompt with instructions on what needs to be created, and then you can come up with your own solution using the given criteria for the exercises. These are meant to be done on your own as a way to think critically about a topic. I'll be going over exercises in detail later on in the course and how to get started. We also have projects. Projects build upon the existing demos by bringing multiple topics together into a single application. Each project is a standalone piece of software with some base functionality. After building a project, you can get additional practice by extending it with your own ideas and features. Lastly, we have the solutions. The source code for the course includes solutions for the demos, exercises, and projects. If you want to see how I implemented an exercise, or if you want to compare your code with what exists in the videos, you can use either git diff to see the differences between your code and mine, or you can switch over to the solutions branch to access a fully working copy of my solution. That's it for this short intro on the course. I'll see you in the next one. Types are the star of the show in TypeScript, so in this video, we'll be taking a quick look at what they actually are. Before we do that, we need to take a step back and look at raw data. Raw data in a computer is binary, meaning either 0 or 1. The computer has no understanding of anything other than 0 and 1, so it doesn't know what types are, it doesn't know what programming languages are, it doesn't have any knowledge other than 0 and 1. So what does this have to do with types? Well, computers are great at handling zeros and ones, but humans aren't that great at it. We're better at actual things or ideas, and this is where types come in. Types bridge the gap between code that developers write and code that the computer can interpret. We can provide some context to the program using the types, which are easy for us as humans to understand. For example, if we want to write a program to display cat pictures, we can create some types that are useful for this purpose. TypeScript will convert these types into the proper binary code for the computer to display cat pictures. This provides us with the best of both worlds. We can use meaningful definitions of things in the code using types, while also generating code that the computer can execute. Since TypeScript is converting our types for us, this means that it has information about them. This information is utilized by TypeScript to track how we're using the types, and this can help us tremendously. Let's take a look at an example. If we write a program about dogs, we can encode this information using types. We can tell TypeScript that it's okay to give baths to dogs. So far with our program, everything is good. Sometime later, the application gets updated, and now it can handle cats too. Since we use types for pet information, we can tell TypeScript that cats really don't like taking baths. Once this information is encoded, if we try to give a bath to a cat, TypeScript won't even let us run our code at all. It will abort because TypeScript is checking how the types are being utilized. This means that it can catch mistakes, like if we try giving the cat a bath. The more types you use, the more information TypeScript has to check your code for mistakes. As a developer, you may be working on just a small portion of a system. Since TypeScript is just another computer program, it is able to not only check your changes, but also make sure that it works well with the rest of the code base, whether the code base is 300 lines long or 300,000 lines long. And that'll do it for our primer on types. In the next video, we'll be discussing variables. I'll see you there. In this video, we'll be talking about one of the most fundamental ideas in programming, and that is variables. When writing programs, you'll be working with lots of different kinds of data, maybe an address, an online shopping cart, or scores in a video game, or maybe even all three in the same application. The computer needs to put this data somewhere in memory, so the shopping cart could be up on the top, and maybe the high scores are there on the bottom. For us, the exact location of data in memory isn't a concern at all. All we care about is how can I get to that data, and that's where variables come in. Variables allow us to assign useful names to these pieces of data, while also automatically keeping track of where they exist in memory. This frees you up to work on your code instead of trying to remember where everything exists. So if we want to access a player score in a video game, we can just use the score variable, and TypeScript will go into memory and pull it out for us. To create a variable binding, we need to use a keyword, and the first one we'll be looking at is the let keyword. When we use let, it allows us to reassign data to that binding later. This allows us to easily make modifications to that variable when we need to. So whenever you have a situation where you need to reassign data back to the same variable, we'll be using the let keyword to do that. We can also use the const keyword to create assign once bindings. We'll mostly be using const when creating our bindings because TypeScript will let us know if we try to reassign data created with const. This provides extra reliability to our programs in case we accidentally try to reassign data that shouldn't get changed. It is important to note that we can still change the value within a const binding, we just cannot reassign it. So using an equal sign won't work, but other methods will still allow the const to be updated. So const shouldn't be confused with immutable. The data can still be changed, we just can't assign entirely new data to it. We also have a third way to assign variables using the var keyword, but this is the only time I'll mention this keyword because you should never use it under any circumstances. It's a legacy keyword left over from the early JavaScript days, and it has some very unconventional behavior that makes it hard to use properly and even harder to read. Luckily for us, the let keyword can do everything the var keyword can do without any of the downsides. So when creating variables, always make sure to use either const or let. That'll do it for variables. Now we can put this into practice in the next video. In this video, we're going to be setting up Visual Studio Code and downloading the course content. So when you first start up Visual Studio Code, you're going to have a welcome screen like this, or you may have a blank screen, or you may have some existing code open that you were working on earlier. Now, if you have existing code, what we need to do is save everything, go to File, Close Folder, then Visual Studio Code is going to reload, and you should have no folder opened here at the top, and we should have a button that says Open Folder. And you'll either have a blank page here or the welcome screen. The important part is we have no folder open indicated here in the Explorer. Next, we're going to open up a terminal so we can close all this. We'll go to Terminal, New Terminal, and we need to clone the repo. So I'm going to provide the repo address. We'll zoom in a little bit. We'll do git clone. And here's the address using HTTPS. And if you use SSH to do your git work, then we can git clone and then use that address for SSH. I use SSH, so I'm going to clone that. So it's going to clone into ZTM TypeScript, and then once it's done, we're going to use CD. So CD is for change directory. We're going to change our directory into ZTM-TypeScript. Now that we're in the TypeScript directory, what we're going to do is type in code, and that loads Visual Studio Code. We'll type in -r, and that's going to reload the current instance because we're in it right now, and dot. Dot selects the current directory. So what we're going to do is reload Visual Studio Code in the project directory. So we'll hit enter, it's going to reload. Once it reloads, you'll see on the left we have this Explorer, and it has all of the course content listed here. We have the app folder, and that has the applications we'll be building. We have the demo folder, which has the demos that will be going through the videos. And we have an exercise folder, which has additional exercises for more practice. VS Code does have built-in support for TypeScript, but there are a couple extensions that I like to have installed to make coding a little bit easier. So if we go down to our extensions right here, the first one we'll have installed is GitLens. So GitLens is right here. We'll click install. And another nice one is Error Lens. So it has this little exclamation point. We'll install that one as well. And Error Lens just kind of highlights your lines that have errors right in your code, so you don't have to look at the terminal. So we'll close that. And what I want to show you is how we can actually view the solutions. So to do that, we'll go to our terminal. We're already in our repo. So what we can do is we can do a git fetch origin solutions solutions. And that's solutions with a colon in between. We'll hit enter, and it's going to pull down all the solutions for all the demos, exercises, and applications. And what that will allow us to do is actually see the changes between your code and the solution code. So just for an example, I'll open up demo, arithmetic.ts. We'll see that the file is mostly empty. It just has a few lines. We right click on arithmetic.ts. We can go to open changes, then open changes with brancher tag. And we're going to click on solutions right here. And what that does is it brings up the code on the left, which is the solution file, and then the code that you have on the right. So you're able to compare what's in the solution file along with all the notes and compare with what you have. So if you find that something's not working properly, you can take a look at the solutions and see where it went wrong. There is one more thing we need to do before finishing up, and that's install the dependencies for the course content. To do so, we can open up a terminal, npm install, and once that's done, you'll be ready to go in the next video. I'll see you there. In this video, we'll see how to create variables and assign data to variables, and we'll also go over a few of the basic types available in TypeScript. So we're going to open up Visual Studio Code. Again, make sure that we have ZTM TypeScript at the top. We always want to make sure we see that. And then we're going to open up the demo folder. So go ahead and click on the demo folder. We're going to scroll down to variables. And then we have two files here. We have a JSON file, and that's a configuration. And we also have a TS file. So all of our TypeScript source files are going to be in .ts ones. So we're going to double click that to open it up. Once it's opened up, you'll see that we have an ESLint disable, and that just disables the linter for the demo files. Normally, you don't want to include this, but for the purposes of the demos, it's okay, because in some of the demos, we're going to be writing code that may not be the best, and ESLint is going to warn us that we're doing it wrong. But that's fine because sometimes we want to do it wrong, that way we can see how to do it right. And so that's why we just disable it, that way we can get rid of any warnings or errors. So with variables, we want to make sure we always use const to start with. Zoom in a little bit here. So we want to use const to start with. If we want to change it, we'll use let, but for the most part, you're going to be using const. So we're going to make a string variable. I'm just going to call it course name, and we'll say that this course is named TypeScript. We always end our lines with a semicolon here. So JavaScript will automatically add semicolons. So technically, we can take that out and it's still fine. However, in practice, you never want to do that because sometimes JavaScript won't be able to figure out where to put the semicolon. And that applies to TypeScript as well. So we want to make sure to always have semicolons at the end of our lines. And when we create a string, we have these double quotes here. We can also use single quotes, so I'll show you the difference. So it's basically the same. We'll have course name 2, and we can also use single quotes. So both are okay, and I think most of the time, you can most projects are going to use single quotes, but you can also use double quotes. So it's really just a preference because there's no standard for it. Whatever one you choose, just make sure you use it consistently across your code base. So either use everything with double quotes or everything with single quotes. We also have back quotes. So if we do back quotes, like course name 3, and we change that to back quotes, we can do that as well. Now, back quotes are something a little bit different than the single quotes and the double quotes, and we will be going over the difference later on throughout the course. Also, with these string types, with the double quote, single quote, and the back quote, there's no difference between characters and strings in TypeScript. So if you're coming from a language like C or Rust, where we have characters and strings, there's no difference in TypeScript. It's all just the same thing. It's all just string. So you can use one character, multiple characters. It's all going to be a string. Next, we'll create a number. So to create a number variable, we just assign it a number. We can also do decimals. And we can also do exponents. So with exponents, we do 1e3, and that's going to expand to 1000. We also have octals. I don't really use octals too often, but if we have 0, lowercase o, and then we can use some octals. That's used in Linux permissions, but as far as programming goes, you probably won't use it too often. I'm just showing it to you in case you happen to see it. You can also do hex. So hex is 0x, and that can make a hex digit. And that could be useful occasionally. We can also do binary directly. If we want to do a binary number, we'll do 0b, and then we can have our binary number. We also have a data type called a big integer. So if we make a big int, that allows the numbers to go really large. And to make a big int, we end it with the letter n, and that'll be a big int. We also have Booleans, so we have true and false. So those are pretty self-explanatory. Yes is true, and no is false. So true and false, we are going to go into detail about how to use true and false and how they compose with other parts of programming. But for now, we're just assigning true to the variable yes and assigning false to the variable no. We have a few more basic data types. We have missing. So I'm naming this variable missing. We're going to do undefined. So undefined is when something completely doesn't exist and we know nothing about it. So that's undefined. And you might run into that a lot when we start working with the front end, because if we have an element in a web page and we try to look for it and we type the name wrong or the element doesn't exist, we're going to be getting undefined back. We also have null, which is almost the same as undefined. The only difference with null is we're telling TypeScript or JavaScript like, hey, we know the thing is not there. So undefined, this means completely missing, and this means we know it's missing. So now we're going to try to make some let variables. We have some number, it's 0, and it looks just like the rest of the things we've been doing, except we use let. Now the difference is, if we take some num, we can assign it to 1, and it's okay. We can also do 2, and that's okay. But if we try to reassign this empty, we try to change null to undefined, we get this error right here. It says cannot assign to empty because it's a constant. So if you need to change something and reassign it, we use let instead. One thing with let, even though we can reassign it, we're not able to reuse the same variable name with let. So if we try to set some num equals to 5 like that, using another let keyword, that's not going to work. So we have to just get rid of the let and just assign some num to whatever number you want. Now, related to that, we'll comment this one out. If you do need to do something like this, instead we can use variable shadowing. Now to do that, we create a new block with curly braces. And within that block, we can now redeclare something we've already used. So we can set some num equal to 5 here and it works, but outside it doesn't. So what happens here, we'll scroll up. Outside of this block, we have some num and it's equal to 2. So right here, so all this point is equal to 2, and outside this block, it's also equal to 2. Once we go inside this block, when we set some num to 5, it's shadowing this some num out here. So this, as far as this block is concerned, some num is now equal to 5, and this one outside no longer exists. It's still in memory, but this block is just ignoring it. And once this block finishes, then we'll go back to some num equals to 2. Then we'll be able to access it and it'll be 2. Now, I don't really see this happening too often in regular code. However, in test code, it can be really useful because you can have multiple test cases and each one can test something different. So for example, if we duplicate this block, we can have some num equals to 5, 4, and then 3. And then we can write our test code to test our functions and test our other things like that. So that way we don't have to keep creating new variable names, because if we want to have multiple test cases, we want to test 5, 4, and 3. And we don't want to have to create new variable names each time. So we can just use these curly braces to shadow them. And that way our test code will become a lot cleaner. Now, I know I'm kind of jumping ahead with testing, but we'll get there eventually. But for now, just understand that we can shadow as long as we use the curly braces. I'm going to delete a few of these blocks. We'll just have one here. Next, we have uninitialized variables. To create an uninitialized variable, we just use let and then the variable name, and then a semicolon. So we don't need an equal sign and we don't assign anything to it. And when we do this, it's uninitialized. Now, one of the reasons you may want to actually make an uninitialized variable is because there would be some cases where you're going to set the data later and you don't know exactly what you want to set it to yet. So let's say, for example, that with our hello variable, we want to have a greeting to greet somebody. And maybe we want to say hi, or maybe we want to say hey, or maybe we just want to say hello. So we want to pick one of these, and later on we'll get to this part, but in between this code, there'll be logic to determine whether we say hi or hey or hello. Now, it doesn't make sense to just pick one. Like, we don't want to just pick hello, set it there, and then later on reassign it to hi and hey. So we leave it uninitialized, and then later on we pick the actual one that we want. Now, the good thing with uninitialized variables is TypeScript will actually give us an error if we try to use it without assigning. So if you need to create one, don't worry about accidentally using it later and not having it be unassigned, because TypeScript will give you an error if that's the case. The last thing I want to go over is using consts with an uninitialized variable. So I'll just call this one whoops, because it's not going to work. When we use consts, we're not able to create an uninitialized variable. And that's because whenever we use const, we only get one opportunity to assign it. And then if we try to say whoops equals 3, That's not going to work because consts have to be assigned immediately. So we have to assign it right there and then it'll work. I'm just going to leave this commented out. Let's put a message error like that. So whenever you need something uninitialized, we have to use let instead. So let for uninitialized variables. And that'll do it for our video on variables and primitive types. In the next video, we're going to be taking a look at Boolean logic. I'll see you there. In order for our programs to make decisions, we need to talk a little bit about Boolean logic. If you've never heard about Boolean logic before, don't worry. It's not complicated at all. Actually, the opposite. You use Boolean logic every day. In real life, deciding yes or no can be used for practically any purpose, and the same goes for Boolean logic. To put simply, Boolean logic allows us to evaluate a Boolean expression and produce one of two answers, either true or false. It can be used to decide whether certain items are displayed on a menu. It can choose which cell phone tower to route a call to, and it can control a traffic signal when someone presses the crosswalk button. Almost anything can be evaluated in terms of Boolean logic as long as it can produce a yes or no answer. Now let's talk about Boolean expressions. A Boolean expression is a combination of any number of Boolean operations. These operations are combined to arrive at a final result, either true or false. Boolean expressions typically use parentheses to specify the order in which the expressions should be evaluated. And the evaluation order starts from the innermost parentheses and ends with the outermost parentheses. We'll be going over the details of Boolean operations and how to write expressions in the next video. For now, let's take a look at an example of how we can use Boolean logic to achieve a goal. In this example, we're going to be walking through a set of Boolean expressions that will be utilized for ordering a product. In step 1, a customer calls to order a product. We can say this is true because the call took place. In step 2, the program searches the warehouse database to figure out if a product is in stock. This search may turn out false, meaning there's no product available. Since we want to sell as many products as we can, we also check the factory to see if any product is scheduled for production. Step 3 searches the factory database and discovers that more product is being produced. So it's true that we will eventually have product ready to ship. After all these steps take place, we can evaluate the results of each one and decide what to do. In this case, we decide that either the warehouse search is true or the factory search is true, then we can schedule the item for delivery at some future date. This is just a simple example of using Boolean logic. As long as we know something can be true or false, we can apply Boolean logic. To sum it up, using Boolean logic to evaluate the result of each step in a program allows for the consideration of multiple conditions, which enable the program to make decisions based on data. And that'll do it for this video. In the next video, we're going to be hopping into some code and applying some Boolean logic. I'll see you there. In this video, we're going to be writing some Boolean logic in code. To open up our demo folder, we're going to go down to our Boolean logic folder and double click on booleanlogic.ts. And you'll see in this Boolean logic TS file, we have our ESLint disable line along with this import line. Now, normally I don't like to jump ahead, but with this import, we kind of have to in this case. What import does is it allows us to take someone else's code and bring it into our code. And specifically this assert module that allows us to confirm that our code is doing what we think it does, which is what we want for these demos. We want to be able to confirm that we're right or wrong with our current code. And we'll see how it works in a few minutes. And in a later video, we're going to write our own modules to be able to import or export things. But for now, just understand that we're bringing in other code and we're using it to test our own code. So as we discussed in the previous video, Booleans are either true or false. So we're going to have yes, that's true. And then we have no is false. Right, and that's the end of the video. No, I'm just kidding. So we can do a little bit more than just assign true or false. So one thing we can do, we can check to see if someone's a certain age. So if we set someone's age to 18, and let's say we have a situation where they have to be at least 18 years old to make a purchase. So if we put can purchase, we can set that equal to age, and we can use greater than or equal to 18. Now when we do this, this is right here is a Boolean expression. So this greater than or equal to, we're trying to check to see if the age, which is 18, we're checking to see if that's greater than or equal to 18. In this case, we think it is. So this can purchase should evaluate to true because we're telling it, our Boolean expression is saying, hey, is age greater than or equal to 18? And it's going to check. It's going to look at this age right here. It's going to see that it's 18. It'll see that this is true, and this will evaluate to true. So that'll get assigned right there. Now to test that that's the case, what we can do is use the assert equal. We can put in our variable name and true. What this will do is it's going to check can purchase and see if it's equal to true. And if it is, then everything's fine. And if not, then we're going to get an error. Now what I want to do before continuing is I actually want to run this before we write some more code. So what we can do is save this. If we look at the top, we'll see we have this circle here. This means we have unsaved changes. So we just need to make sure we save our code. Then we need to open up a terminal. You can use an external terminal if you want, or you can use the built-in terminal. The built-in terminal can be accessed from terminal, new terminal, and you can use it right here, or you can use an external one. I'm going to be using an external one for screen space. So I'm going to close that. So in our terminal, we're going to use p npm exec ts-node. After that, we're going to type in the path to our Boolean Logic demo. So we have demo Boolean Logic folder / Boolean Logic.ts. What we're doing, we're accessing the p npm program to run our node modules. Then we have exec, is short for execute. ts node, what that does is it runs TypeScript files, the ts, so that's for TypeScript. It runs TypeScript files in node, and then we just specify the file that we want to run. Since we're on the Boolean Logic demo, we want to run the Boolean Logic.ts. So we hit enter, and nothing happens, which is what we want. Now the reason nothing happened is because this assertion is true. So if we just change this to false, I'm going to change that, save it. I'm going to run it again. And so if it's false, we get this error. If we scroll up, it says right here, expected values to be strictly equal. And it's telling us that true, which is this can purchase, is not equal to false, which is the false that we're checking. So if you get an error, that means that your code is incorrect. Then we also have on the bottom, it has actual is true, expected is false. So this is the actual value here, can purchase, and the expected value is right here, false. We're going to change that back to true. So since we have greater than or equal, we also have other operations such as less than or equal, equal to, greater than, things like that. So if we want to do the opposite, and instead of can purchase, we want to deny purchase. So anytime the age is under 18, we're going to deny the purchase. So this should evaluate to false because our age right here is 18, and 18 is not less than 18, it's equal to. So this should be false. If we want to test equal to, let's say we have a favorite color. Let's say it's yellow. So you can make a variable called isFavorite. If you prefix a variable with is, this is kind of like a hint that we're working with a Boolean. It's not, you can name it whatever you want, but I find that using is kind of helps a little bit. So we know is true or false. So yes or no, isFavorite. We have isFavorite equals to favorite color. We use 3 equals to compare things. It's not, so a lot of languages use 2 equals. In TypeScript, we're always going to use 3 equals. So we'll see if the favorite color is red. I'm getting an error here, so let's see what's happening here. Here's if you're unintentional because type's yellow. Okay, so what's happening here is TypeScript is smart enough to know that favorite color has to be yellow, and we're trying to compare it to red, and TypeScript is saying, nah, you can't do that. I know this is yellow, so this isn't going to work. So I'm going to try to trick it a little bit. So instead of that, we'll just do some math. So we'll take 1 plus our variable 2 and see if it's equal to 3, see if that works. All right. So now we can do our assertion. So we expect is 3. That should be true because we're taking 1, and this variable 2 has the number 2 inside. So we have 1 plus 2, and that should be equal to 3. And so we want to set that to true. Remember, always 3 equals. It's really easy to accidentally put 2 if you're coming from a different language, but TypeScript is always 3 equals. Now to check to see if something is not equal, what we can do is, I'll make another constant. I'll say is not 3. We'll do 1 plus 2 is not equal to 10. So we know it's supposed to be 3, but we know it's not equal to 10. And so is not 3 will also be true. So for not equals, we just use an exclamation point and then 2 equal sign. So whenever you're doing equality, we always need 3 things, either 3 equals or an exclamation point and 2 equals. So 3 characters for whenever we're doing equality. And so now we'll finish up with just a table of all of our equality operators. We have less than or equal to. We have greater than or equal to. We have equal to with the 3 equals, and not equal to with the exclamation point. And so those are all of the equality operators that we can use. There is one more Boolean operator that I do want to talk about, but I'm going to save that for the next video. So I'll see you there. In this video, we're going to be talking about compound Boolean expressions. So we're going to jump into our demo folder. We're going to go to compound-bool and open up compoundbool.ts. So the first thing we're going to do, I want to go over the one operator that we didn't cover in the last video, and that is Boolean not. So not just inverts a Boolean. So if we have a variable called writing, and let's say we're writing, like we're writing code. I also have a variable called reading. So if you're either reading or writing, we don't do both at the same time. So we can use not to invert the value of writing. So if writing is true, which it is here, then we have exclamation point not. So not writing is false. So anytime we have the exclamation point right here, that's going to switch true and false. So if we start with true, that's going to become false. And if we start with false, that's going to become true. Next, we have Boolean or. So this is going to be called or. This is not. So for or, this will be for rating, making movie suggestions. So let's say we rate a movie as a 9, and we also have favorite movie. This will just be for one particular movie. So this will be the data for the movie. We rated it 9, and it's not our favorite movie. So then if we jump ahead and we have a suggestion algorithm, and ultimately it has to suggest a movie. So what it's going to do is going to look at the movie and see if the rating is greater than 8. And if it's greater than 8, then it will suggest it, because that means you rated it high, so you might like it to watch it again. Or if it's our favorite movie, then we're going to suggest it, because it's good to watch your favorite movie again because your favorite and you love to enjoy it. And so what we have here is a compound Boolean expression right here. So what we do is we have these pipes. These are called pipes. We call them bars as well. Pipes mean or. So that's Boolean or. So that means this expression or this expression has to be true. And if either one of those is true, then the value of true will get placed into suggest movie. In this case, our rating is 9. So this will evaluate to true automatically. And or is short circuiting, which means once we get a true, like we have here, the rest of this is going to be ignored. Let's add our assertion here so we can confirm what we think is happening. So this is going to be suggest movie, and that's going to be true. We'll add our assertion up here as well. So reading, and that should be false. So the next thing we're going to look at is Boolean and. So for Boolean and, we're going to set an age to 18, and we're going to check to see if that age is a teenager. So what we can do, we can take age greater than or equal to 13, and we use 2 ampersands for and. We want to make sure the age is less than 20. We'll add our assertion. So with Boolean and, when we use that, all of the expressions that are connected with the and need to be true. So we need to check this expression first to see if age is greater than or equal to 13. The age is 18, so that checks out. That's true. And we need to make sure the age is less than 20. 18 is less than 20, so that's also true. Since both of these are true, true will be set here as is teenager. So the value of is teenager will be true. Now this is kind of the opposite of or. What happens with or, when we have or, as soon as one is true, then automatically it goes into the variable and it gets short-circuited. And is kind of the opposite. As soon as we have one that's false, then the whole thing gets ignored, and then false will get placed in there. That's because and we need to have everything true. So as soon as we have one false, then there's no point in checking the rest because we know it's going to be false because not everything is true anymore. So if we change age to 12, so 12 is not a teenager yet. What's going to happen is we're going to hit this first expression, greater than or equal to 13. That's going to be false. And the rest of this is going to be ignored. So is teenager will be false in that case. All right, so we'll change that back to 18. Now, the next thing we're going to do is we're going to string a couple of these together. So this will be for determining whether we have to pay a fee for shipping a package. So we'll set the package weight to 30, and we'll set the package length to 50, and this will be our package. We're going to have a fee exemption. So fee exemption will be maybe you have a contract with the shipper or you have a coupon or something. And so we don't have a fee exemption. So ours is false. So we're going to have to pay a fee potentially if our package is too big or heavy. So now we need to make another expression and to see if we even need to charge the fee. Then once we get to that point, we know if we charge a fee, then we can do the math to apply the fee based on other data. So first thing we're going to do is negate the fee exemption, and we're going to do some more stuff. So what's happening here, we're negating this fee exemption. And the reason we're doing that is because we have and. And so if we just read this, instead of saying like not fee exemption, that's kind of weird. If we just say, instead of not, we just say don't. So if we don't have a fee exemption and whatever we put here is also true or false, then we're going to set the fee here. So the reason we negate that is because if we do have a fee exemption is true, meaning we're going to negate the true here, and that'll be false. And since we're using and, this false is going to automatically short circuit and say that we don't need to charge an extra fee. So that's why we're negating this. So if we don't have a fee exemption, which means this is false, and that's going to turn out to be true because we're negating it, then we're going to have to check this as well. And we're going to write that code now. So we're going to check to see the package weight and see if that's over 25, or the package length is over 40. I'm going to zoom out slightly so we can see the whole thing. So now that we have the first part, we check to see if we have an exemption. And if we don't have an exemption, then we're going to check here. We're going to check the package weight to see if it's greater than 25. Our package weight is greater than 25. It's 30. So this is going to be true, and automatically we're going to have to pay a fee. But if our weight was less, like let's say our weight was 10, then it's going to check. So if this was false, then it's going to go here and check the package length to see if it's greater than 40. Our package length is 50, which is greater than 40, so that's true. So we're paying a fee no matter what, because we don't have an exemption. Our length and our weight are both over the maximums for having to not pay a fee. So one thing before we finish up, I do want to note that when you have more than one and or more than one or, that's kind of a signal that we should start packaging up this line of code into separate units. Now, right now we only have these three things that we're checking, but you could imagine if we also had something like, for example, we had shipping distance, and then we had like air or ground. And then if we start adding more things like priority shipping, like we want it to show up the next day or something. So now we would have all these things to check, and this is going to start getting huger and huger. And even just with, if we delete those, and if we're only concerned with just these three, already this is starting to become complicated, because if we flip this, or if we change that to an and, or one little tiny mistake, and the whole thing is going to be running incorrectly, and we don't want to do that. So what we can do to try to make this a little bit easier is we can actually pack these into individual units. So once you start having multiple ands and ors, we're going to split these into separate units. That way we can just focus on the one unit. So if we're working on this one with dimensions, we can ignore everything else. Or if we're working on the unit with fees, we could ignore all dimensions. And that's going to make our code a lot easier to read in the long run. And so over the next few videos, we're going to learn how to do that. And that's going to help increase the reliability of our code. So that'll do it for this video, and I'll see you in the next one. In this video, we're going to be going over some basic arithmetic. So if we open up the demo folder, go to the arithmetic folder, and then open up arithmetic.ts, we'll see we have this link here, and that just links to additional math operations that we can do. We're only going to be covering a few of them, but I will show you how to use the math module as well. So to get started, we'll just do some addition. And I believe we already did some addition previously. So to do some addition, we use the plus symbol. So we can take 1 plus 1, and that's going to be equal to 2. Pretty self-explanatory. And for subtraction, I'll just name this sub. We can do 2 minus 1. Use a dash for subtraction. That's going to be equal to 1. Multiplication uses an asterisk. So this can be 3 times 3. That's going to be 9. We also have division. And division is when things start getting interesting. So we can do 8 divided by 2. That's going to give us 4. Now, if we start tossing in 0, we start getting some interesting things. So I'm going to say we're going to get infinity if we take some number divided by 0, then the result is actually going to be infinity. So I'll just name that INF. If we have infinity with the capital I, that's actually a special keyword we can use, and that's going to mean infinity in terms of math. So if you divide a number by 0, then you're going to get infinity. Now, if you divide 0 by 0, you're going to get NaN, which is short for not a number. So if we can use this isNaN function to check to see if something's not a number. And so if we divide 0 by 0, we get not a number. And if we divide 1 by 0, we get infinity. And so essentially what this means is you want to try to avoid dividing by 0 as much as possible, because you're not actually going to get an error in your code back. You're just going to get infinity, or you're going to get not a number. You might even get negative infinity. Because I believe if you do negative 1 divided by 0 or 1 divided by negative 0, you might get a negative infinity back. And that's a lot of weird edge cases to test for. So if you just check your code to make sure that you don't have 0 when you're doing division, then you could avoid looking at all this. And that's what I would recommend you do, is just avoid 0 altogether. We can also do remainder division. So to do remainder division, we do this is a percent symbol. So we do 10 remainder division 3. And what that's going to give us is a result of 1. That's going to be 1. So with remainder division, 3 will go into 10 3 whole times, and there's 1 left over. So that's where we get the 1. We can also do a negation. So if we negate something, like if we negate a remainder answer, so remainder is 1, we do the minus symbol before the name, then we're going to get negative 1. So it's going to just negate whatever we happen to have. So this will be negative 1. And if we negate it again, so if we negate the negation, then now it's going to be positive 1. So you can just keep flipping back and forth. We also have exponents. So for an exponent, we're going to take 2 asterisks. So that's going to be 2 times 2 times 2, and that's going to equal 8. I just want to double check on my math by running this. So I'm going to hop into a terminal, do p npm exec ts node demo /arithmetic /arithmetic.ts. All right, so all my math is fine. So most of this should also work with decimals and things like that too. So for example, multiplication, we can do 3.5 times 3, that's fine. We can use scientific notation, that works as well. I think we can even do hex. So if we want to do hex, when I multiply ff by 3, we can do that as well. I think the only thing that won't work is big integers. Yeah, so we can't use big integers. The big integers have a whole separate way of doing things. If we want to use the math module, because I mentioned the math module at this link, the link has the list of everything we can possibly use. But I'm just going to show you how to use 1 or 2 of them. So if we to access the math module, it's already built into TypeScript and JavaScript. So to access it, we just use math dot, and then we can pick what we want to use. So if we want to use ABS, it's for absolute value. So if we do absolute value of -5, then we're just going to get 5 back. So I'm just going to say I'll call that ABS. And so that's just going to be 5. That's absolute value. And same thing for anything else. So if we want to access pi, we can just use math.pi, both caps. And you'll see that we already have this popping up because TypeScript has all this built in. So it knows exactly what functions and what everything is available. So if we just type in math.pi and we can get pi. That's useful if you want to do any calculation with circles, of course. And that's all the basic math operations that we're going to be covering. Like I mentioned before, if you want to do more advanced mathematics, we do have the math module right here that you can use. And that'll do for this video. In the next video, we're going to be covering incrementing and decrementing. I'll see you there. In this video, we're going to be working with the increment operator and arithmetic assign operators. So to get started, we're going to open up the demo folder. We'll go down here to increment and open up increment.ts. So incrementing is a really common thing to do in programming, and TypeScript and JavaScript have a built-in way to increment numbers. So we'll start with a number. We'll set n equals 1. And to increment, we just take the variable we want to increment and have 2 pluses. And that's it. So now it's incremented. So we'll just test it. So we have n equals to 2. We'll hop into our terminal, make sure that we don't have any errors. And there we go. So now it's 2. Now there's also another way we can increment it, and that is plus plus, then the variable name. And that's going to do the same exact thing. So now we have 2. We do plus plus n. So now we're going to have 3. So this first one is called postfix. That's postfix increment. And the second one, this is called prefix increment. Now there is a subtle difference between them, and we're going to go over the difference right now. So we're going to start with n. We're going to set it to 5. Now if we take the postfix increment, we'll make a new variable. We'll take n plus plus, and so now k should be 6. So we have k 6. And that makes sense because we have our n is 5, and then we just take n plus plus to increment it, and so k should end up being equal to 6. Let's hop into a terminal. We'll run it, and we see we actually got an error. So we have actual is 5, and our expected is 6. Let's hop back into our code. So we expected this to be 6, but the actual value is 5. So what's going on here? What I'm going to do is split this up. This n plus plus is actually 2 operations. So when we do n plus plus, it's going to take n, it's going to stick that into k, then we have a second operation, which is the plus plus. And then once the second operation happens, it's going to take n and then just add 1 to it. But once this addition happens, the n was already saved previously. So that's why k is 5, because the n was moved here, and then later on it gets added. So what happens, we take assert equal, comment that one out. We take n, and n is actually going to be equal to 6 now. So the k is just 5. So there we go, no errors. So you don't really want to use plus plus with an assignment like this because you could end up with subtle bugs. Now, if we do the same thing with the prefix, we'll say this one is j. We'll do plus plus n, then we'll do an insert equal. So we'll check j, and j should be equal to 6. So when we do this, we take plus plus n, and that's all one operation. So we take n, add 1 to it, and then the whole thing gets saved into j. So if you do need to use an increment and assign at the same time, then use the prefix version because you're not going to get any problems with that one. We just test it. We can see everything is fine. Now, a way to get around both of these issues, well, before we do that, we also could decrement. So we'll reset n again. We'll call this one, this can be t. So we can do minus minus n. And so minus minus is just the opposite of plus plus. It's just minus 1 instead of plus 1. So if we do assert equal t, this one should be equal to 4. It was minusing 1. So now we're going to look at the arithmetic assignment, which is what I recommend using over the plus plus and minus minus. So we're going to reset n again. Now to use the arithmetic assignment, we just take the variable that we want to work with, and we can use plus equals 5. What that's going to do is it's going to take n, and it's going to take whatever n happens to be right now and add 5 to it. So this will end up being 10. Let me add our assertion. So this will be 10. And then we can do minus equals as well. So we can do minus equals, and now it's going to be 5 again. And we can also just do 1. So if we wanted to do 1, we can do minus equals 1. And then it's kind of like a decrement at that point. So we can minus 1, that's fine too. So when you use the arithmetic assignment, like this, there's pretty much no room for errors with this because there's no weird thing where if you, like what we have up here, where if we do it first, then it's okay. And if we do it afterwards, then it's sort of okay. If we want the wrong value here, but that might not be wrong, and we just don't know. And it's better to avoid all that headache and just go straight to arithmetic assignment here because it's really clear. If we want to add 5, we just do plus equals. If we want to subtract 5, we do minus equals. And that's what's great about the arithmetic assignment is we're not just limited to 1. We can set any value here. It'll work. One last thing is a quick table. So with the arithmetic assignment, we have plus equals, we have minus equals, we can do multiply equals, and divide equals. And I think we can also do remainder division equals. There may be more, but you probably won't need to use any more than just these ones. And that'll do it for this video. I'll see you in the next one. Now I'll be talking a bit about functions. Functions are an essential building block in all of programming, and TypeScript is no exception. When a program runs, it executes a set of steps, and those steps are coded by the programmer. Some programs may be simple with only a few steps, and others may be complex with many steps. Regardless of how complex a program gets, being able to organize it is very important, and this is where functions come in. A function is the most basic organizational unit of a program. Functions can perform any number of actions, and they can contain anything. They can have a single Boolean expression, or they can have complex logic for reading a programming language. Functions allow us to encapsulate logic into a single package, and once that logic is encapsulated within the function, it can be reused anywhere else in the program. This makes it easier to read, to write, and to test your code. For a function to do something, it requires some data. To specify what the function works with, we use something called function parameters, or just parameters for short. Functions can have any number of parameters, although it's best to limit them to 5 or less in order to make the function easier to use. Let's take a look at an example of how functions work. Here we have a function that requires a color, a sound, and a word. These are called the function parameters. To execute the code within the function, we have to call it. You can think of calling a function like you would calling a phone number. You may not know where the person is right now, but you have their phone number and you can call them. Functions work the same way. As long as you have the function name, you can call it and execute the code within. When calling a function, we need to provide data for the parameters. When data is provided for functions, we call the data arguments to the function. So parameters define the data accepted by the function, and arguments are the data that's provided to the function. So these right here are the parameters, and these are the arguments that we call the function with. Our example function here needs 3 arguments, a color, a sound, and a word. If we provide the correct arguments to the function, then the function will execute. Here we provide red, woof, and hello. When making a phone call, both parties can exchange information, and the same goes for function calls as well. The caller provides information using arguments here, and they call the function, and then the function is able to return data back to the caller as well. It's important to note that when functions are called, the correct arguments must be supplied. If we provide the arguments in the wrong order, like in this example, then we'll get an error. Since the word by isn't a color, TypeScript will refuse to call the function and will provide us with an error message. And the same goes for red not being a sound. For the purpose of this example, we'll pretend that meow is actual audio data and not the word meow. So that's wrong too for this function. Now, the great thing about TypeScript is all of these checks will be happening as you're writing your code. So you'll know right away if you accidentally use a function incorrectly. And that's the basics of functions. They provide reusable building blocks, which can be pieced together into an entire program while also making it easier to read and write code. And that's it for this video. I'll see you in the next one. In this demo, we're going to be working with functions. To get started, we're going to open up our demo folder, scroll down to the functions folder, and double-click on functions.ts. So we're going to start by creating a function that has no parameters, just to keep it simple. So we use the keyword function. I'm going to name mine, say, hello. And so what this is, we've just created a function. So we have to have the keyword function, followed by name of the function. We always have to have these parentheses here, even if we don't have parameters. So if you do have parameters, you need it. If you don't, you still need them. Then we have these curly braces, and these curly braces indicate the beginning and end of the function. The inside of the function here is called the function body, and this part of the function with the name and the parentheses is called the function signature. And we'll see in a few videos why the signature is extra important. Within this function, I'm going to access the console, and then I'm going to call the log function with the word hello. So what we're doing here is we're accessing the console module, and we've been doing that with the assertion module as well. So we're accessing the console module, and within that module, there exists a function called log, and we call it by using parentheses. So we have the parentheses here and parentheses here. So it's either creating a function and it has parameters, or we're calling a function and we have arguments. The log function needs a string for an argument. It could also work with numbers and other things, but we're giving it a string. The string has double quotes, and we're just going to say hello. So whenever we call our say hello function, we're going to log to the console the word hello. Now we can also, the console may not be a terminal. It might be a web console or any kind of console. It really doesn't matter. It just depends wherever you happen to be running your actual code. So we're going to call this function now. To call the function, we just type in the function name. We don't need any parameters, so we can just leave the parentheses empty. And that's it. We call the function. So once code starts executing, we're going to load the program. This function is going to get loaded into memory, and it'll be ready to go, and nothing's going to happen until we call it. Execution then gets to this line. We call the function. Then we'll jump into here, do console.log, and we'll see hello displayed to the terminal. Let's do that now. Make sure your work is saved. We'll hop in, we'll run it, and we should see hello displayed. And there we go. So we see hello displayed right there. Next, we're going to create a function that actually has parameters. I'm going to call it sum, and we're just going to add some numbers together. We'll use LHS and RHS. That's going to be for left-hand side and right-hand side. If we want to return some data, because in this case, we're just going to add things together, we want to return the result. So we're going to use the keyword return. We're going to take the left-hand side and add the right-hand side to it. So this is just a slight modification of our existing function. There's not much new. All we have our function keyword, name of our function, we have our function parameters, and we have two parameters in this case. And once we have parameters, we're able to access them within the body. So LHS and RHS are accessible here, and we're doing so right here. We're adding them together, and we're returning the result of that addition. So they're going to get added together. This is going to get returned out, and then we can access the sum of those two numbers. So let's call the function. We're going to create a constant, and we'll just say answer equals sum. We'll do 2 and 2. And then we're also going to use console.log, and we're going to print it out. We can log the answer directly. So what's going to happen here is we're going to call a function sum. The result of adding 2 and 2 together will get placed into answer. Then we call the log function, and we're going to send the answer into the log function and print it to the terminal. So we should see 4 when we run the program. Let's try it. We have hello and 4. And so we are going to do a few more functions, but everything comes down to these two concepts. We have a function with no parameters up here. So we have no parameters at the top. And then we have some with parameters, and you can have any number of parameters. You can have no parameters. And all we're ever doing is we call functions and we write functions. And that's going to be 90% of your work is just writing more functions to do things. So we just want to make sure that we use proper names. That way we know what we're working with. So we don't want to name sum to something that makes no sense for adding things together. And that way when we read our code, everything kind of flows really nice. So one thing we can do, we don't actually need to include constants here. Like we have 2 and 2. We can also take that answer and use that as a function. We have answer 2. We can take that since that's just a variable. We can do that. Now we're going to have 6. We'll do cert equal. So answer 2 is going to be 6 because we're taking 4. We're adding 2 to it. So we can take this answer. We can send that into another function call. We're also able to nest function calls. So whenever we call a function, it's in what's called expression position. So if we do an answer 3, we'll just say answer 3. We can take the sum, and we can also sum again. So we can take the sum of 1 and 1 and the sum of 2 and 2. And then our answer going to add all that together. So we're going to have 2 and 4, so this should be 6. I'm just going to run this to make sure we don't actually crash, just to check my math. All right, so that's good. So what's happening here, we have sum, and for the LHS, the left-hand position, the sum function is going to get called again. It's going to add 1 and 1 together, and that'll get changed to a 2. And then we'll do the same thing over here. So 2 and 2 will get added together. That'll get changed to a 4. And then we're going to sum 2 plus 4 together, which is going to equal to 6. And then finally, that answer gets placed right here. Now, once we start nesting things like this, it can kind of become unclear fairly quickly, kind of like having multiple Boolean expressions all smashed together in one line. So what we can do instead of just nesting everything like this, we can instead compose the answer of multiple function calls. So we can use the left-hand side, using the same example as above. Left-hand side is sum of 1 and 1, and then the right-hand side is sum of 2 and 2. And then our answer is going to be sum of LHS and RHS. So here on the bottom, this is the same thing as this one up here. It's just a lot more clear. So we don't have to try to figure out which one's going first and which one's going second and things like that. And this isn't too bad because we only nested it a single time. But if we start doing stuff like this, like if we had sum 2 and 1, then we have this one here, 2 and 2, or 2 and sum. There, if we have something like that, then I have no idea what that's going to become out to because that has a lot going on. And we don't want to do that. So instead, if we break it apart into multiple pieces and then put the pieces together, then it'll be a lot more clear what's actually happening in the code. And that's going to be kind of a theme with all programming, is breaking things up into as small a piece as you can and then putting those pieces together to build something large. And the better you get at breaking these things apart, then the easier your programming is going to be. So that covers the basics of functions. Just like Boolean expressions, where we're going to be using a Boolean expression every couple lines of code, same thing with functions. Every 5 or 6 lines, we're probably going to have a new function that we're going to write. So we're going to get lots of practice with functions. So if it doesn't completely click right now, don't worry, because from here on out, we're probably going to be writing many different functions. And that'll do it for this video. I'll see you in the next one. In this demo, we're going to be taking a look at template strings. To get started, we're going to open up the demo folder. We're going to scroll down to template strings and open up templateststrings.ts. So what template strings allow us to do is it allows us to substitute data within a string. That's going to come in handy a lot because there'll be many times where you need to include different data within a string. For example, if you want to greet somebody on a web page, you're going to say, "Good morning, person's name." And you won't need some way to put person's name into that string. That's what template strings allow us to do. So we're going to create a function, and it's going to contain a template string. I'm going to call it greet, and it's going to take some kind of message. Within this function, we're going to log. This is where the backticks come in. So remember I mentioned before that we have the double quotes for strings. We have double quotes, we have single quotes, put a space, and we also have the back quotes. So this is the back quotes. This is where template strings come in. So we have back quotes. We have to use back quotes. We'll say hello, $, curly braces, and then a variable that you want to substitute. So it's very important that we use backticks because the backticks are going to tell TypeScript that to read this as a variable instead of an actual string. So if we change this to double quotes, then it's not going to work. It's just going to print out hello, $, message, and that's not going to make any sense. But when we use back quotes, you'll notice the font color changes as well. So it's going to say hello. TypeScript is going to look for this variable named message, and it's going to pull it out from here. So this is going to get substituted here in our string, so we can greet with any message that we want. So if we call this function, we'll say greet. Now let's use TypeScript. If we run this program, the terminal should indicate hello TypeScript to us. So we'll do that now. So we'll exec ts node demo / template string. And so now it says hello TypeScript. So this is the simplest thing we can do with template strings. We can just take a single variable and stick it in the string. It's also possible to put expressions within a template string. So let's say, for example, we're keeping track of number of kids and adults. Like let's say they're going to go to theme park or something. So we have the total number of people. We'll use backtick. There are, and then we start our substitution, kids plus adults. And that's going to add those kids and adults together. And so since we have 2 kids and 4 adults, we add those together, kids plus adults, that's going to be 6. So if we log that, we do console.log, and we're just going to log total people. And run that again. And so we have, there are 6 people. So just like nesting functions, we don't want to put too many things here in the template string, because then it's going to be hard to separate this part of the string with the part that's being calculated. So if it becomes too complex, what we can do is we can actually separate this part out. So instead of kids plus adults, we can say const total attending, and this will be kids plus adults. And we'll change this to message. So now this will be, there are total attending. So that's a way you can kind of simplify it. That way the actual string itself doesn't become too complicated. Now there's one more thing we can do with the template strings. We can actually put template strings into other template strings. So instead of doing console.log with the message, what we can do is we can start a new template string. We can put our message, and we'll turn this into a restaurant. So what this is going to do is we're going to take this existing string that we created, and we're going to use, and this is also a template string, and we're going to put it with this other template string. And so we're going to make a one complete string at the very end. This by composing 2 different ones. So this message is going to get sent here, and the whole thing should say there are total number of people to seat at the restaurant. Let's just run this to confirm. And there we go. So we have our hello TypeScript, and then we have our complete string that's been composed from 2 template strings. And that's all the interesting parts of template strings. They just enable us to easily create strings by composing other strings and pieces of data into one complete message that we can then use later on in our code. And it does so clearly without any ambiguity. That'll do it for this video. I'll see you in the next one. In this video, we'll be taking a quick look at how to work through the exercises. So we're going to start from the demo folder. And as you know, we've been going through these folders based on the topic. Now, let's say, for example, we're working on the functions demo. The folder name is functions. And let's say we want additional practice on functions. What we can do is take note of this folder name, hop on over here to the exercise folder, and look for a corresponding folder with the same name. So here we have a folder named functions, and this is going to have exercises on that provide more practice with working with functions. We can open up 1.ts. So after opening the file, you're going to be greeted with a prompt, and the prompt is going to kind of explain a situation, and you need to code a solution. And each prompt is going to be different and have different requirements and different steps that need to be taken in order to actually complete the exercise. So here's the one for functions. We're not going to actually code this because I want you to do it, but it has a prompt that says that you're supposed to be using functions and template literals to print out your first and last name and your full name, and you're only allowed to use functions and template literals to do so. So many of the things that we cover, it's possible to implement it in different ways. But in order to get the most benefit from the practice, you should stick to the requirements and any restrictions that are applied in the actual code here, or the actual prompt. So here it says use a single function to do this, and a single function for last name, and a single function for full name. So you should follow these requirements in order to properly complete the exercise and get the most out of the practice. Now, as I mentioned, all the prompts are going to be different. So this is the one for functions. It's quite short. It's only like a line long. But if we hop on over here to classes, which you can take a look at later, this prompt is pages long. It's scrolling. It's like 50 lines long almost. So each one is going to be very different. Some are going to be really short because the topic doesn't require much explanation, and some are going to be elaborate situations like this one. In order to actually complete the exercises and check your work, most of them are going to have instructions on how to do that. And it'll say right here, it says perform the following steps to confirm that your class works correctly, and it's going to tell you to do these steps. And so after you run your code, then you shouldn't get any errors. And a successful run usually means there's going to be no output, or it's going to output something that the prompt told you should be output. And just like the demos, if you use Git to hop on over to the solutions branch, you'll be able to see my solution for these particular problems. So if you get stuck and aren't sure what to do, you can look at my solution for hints or see how I did it after you have done yours. So you can kind of get like different perspectives on how it could be implemented. That'll do it for this video. I'll see you in the next one. In this demo, we're going to be taking a look at type annotations. We'll open up the demo folder. We're going to scroll down to type annotations and open up typeannotations.ts. We need some data to work with to start. So I'm going to make a constant name, my name. You can just put your name in here. We need an amount. So it's going to be 2 plus 2. Also going to use a template literal. So we'll use my name. And we're also going to use a big integer. So we'll have power level of 9,000. We use n to make a big integer. And we're also going to have a Boolean. So if you've written JavaScript before, you may notice that we haven't actually written any TypeScript code. It's just been plain JavaScript code. The only thing different that we've done is instead of .js, we've used .ts for our file name. Now, even though we haven't been using any TypeScript specific features, we are actually getting benefits from the TypeScript compiler. And so let's mouse over this amount here. TypeScript is able to figure out that 2 plus 2 is a number, and it assigns that with this colon number. So TypeScript behind the scenes has been checking your code already that we've been writing. And with hello, it knows it's a string. It knows power level is a big integer because we have the n's here. And it knows yes is always going to be true because we set the value to true. So we have been benefiting from TypeScript even though we haven't really done any TypeScript features. That's one of the best things with TypeScript is you can just take all your JavaScript code, throw it into a TypeScript file, and automatically start seeing benefits right away. Now, what I want to do is bring these types right here into our code through type annotations. So we can add type annotation just by copying what was actually shown. So this one's a number. This one's going to be a string. Our power level's a big integer. We use big int. And yes is a Boolean. So now we've brought these types into our actual code. And what that's going to do is that's going to tell TypeScript whatever variable we're working with, it has to have this type. So for example, we have amount. And when we have this annotation, we're telling TypeScript that amount must be a number. We're saying it has to be a number, otherwise it's wrong. 2 plus 2 is a number, so TypeScript says, okay, your code is good. If we were to change this, for example, we'll just change this to the letter A. So if we change this to an A, we're getting an error right away. So it says type string is not assignable to type number. And that makes sense because we're telling TypeScript that for this variable amount, we have to have a number, but we're giving it a string. So TypeScript says, nope, you can't do that. It's not going to work. So the way to fix that is we just have to have some kind of number. Now with our small code sample, this may not seem like a big deal because we're not calling any functions. But as your code base gets larger, maybe this amount is something like some function that's deep in some module, and we have no idea if that returns a number or not. But we don't need to worry about it because if it doesn't return a number, then TypeScript is just going to tell us, hey, this super long function doesn't actually return a number. You got to go take a look at that. That's what the type annotations can help us do. Next, we're going to annotate a function. We're going to write a quick function. We're going to use the same one that we've been using. So we'll do the sum with left-hand side and right-hand side. That's going to have a total. And we're going to return that total. So nothing complicated going on. We're just adding two things together. I want to call this function a couple times. So we'll have 1. That's going to be sum of 1 and 0. I'm going to log it. And we're going to just duplicate this. So this will be 2, and we'll have sum of 1 and 1 as a string. All right, so everything looks good. We have no errors. So let's just run it and see what we get. So to run this, we'll run the type annotation. So we just use p-npm exec as we have been doing. We run that with .ts. And so here's our results. Our first result is 1 plus 0 equals 1, and we get the number 1. And our second result is this string. It has a number 1 here, and then the word 1. And that's because we gave 1 as a string to the sum function. Now, it should be pretty obvious that this is not what we want. So when we add sum, we're expecting to give numbers to this sum function, but we haven't actually told TypeScript that this function takes only numbers. And so we have 1 and then 1 in a string, and it doesn't do any conversions, and we just get the whole thing mashed together, and we don't get any errors or anything. Now, that's problematic because this little string here, this can get passed around later on at your program. Maybe it's like 30 functions deep, and all of a sudden a function crashes because it's expecting this number here, but it's getting this string that's completely wrong. And so having it like this, which is just regular JavaScript code, that would end up having latent bugs if we call it like this, because we don't get any errors right now. We don't get any errors at runtime, and we may not get any errors until months from now when someone just puts in just the right data to cause this error to occur. And we can fix this with TypeScript and type annotations. So we go up to our sum function, and we're going to add an annotation on the parameter. And we're going to say left-hand side must be a number, and that the right-hand side must be a number. And so right away, down here in our sum function is giving us an error. It says argument of type string is not assignable to parameter of type number. So when we call the sum function, we have the second argument is a string, and the parameter for sum must be a number. And TypeScript is checking this for us. It's checking, hey, is 1 a number? Nope, it's not. And so now we have an error, and your program does not run. It doesn't even compile. And we have this error right here in our ID. So the only way to fix this is to change this 1. We're going to change that to the actual number 1. And now our function is working properly. And if we run the program again, we should actually get 1 and 2, which we do right there. So far, so good. We just added 2 words to our function signature, and all of a sudden TypeScript is able to catch errors like this where we had the wrong data type sent, which is great. And we can actually go further than this too. So let's take a look at another example. If we actually delete this return line, everything's fine. So we're expecting to make a sum of the numbers with whatever numbers are in, and we're supposed to return the value. And I just deleted the return line, so we're not going to return nothing. And TypeScript is okay with that because no big deal. It's still valid JavaScript, it's still valid TypeScript, everything's cool. Let's run it. And now we get undefined as our answer. And undefined, we really don't want to see that pretty much ever in JavaScript or TypeScript. But here we have 2 of them. And that's because we didn't actually return anything. So we can have TypeScript catch this error for us as well. What we can do is we can add a type annotation to the end of the signature, and this will be the type of data that must be returned from the function. So if we do this, we're telling TypeScript that this sum function must return a number. And as we can see now, it's giving us an error again, just like before when we made the change. We take a look at this error, a little bit long. We have a function whose declared type is neither void nor any, must return a value. And in plain English, it's saying that we're not returning anything, and we need to be returning a number. So to fix this, we need to return our total. And now everything is fine again. So now it's impossible for us to call this function with the wrong data, and we always make sure that we have a number back. So we can't edit this function later in the future. Like maybe we start adding a whole bunch of code, we have a bunch of lines, and then we forget the return. Now we get an error right away. So we know we're never going to forget the return. It's always going to return values no matter what. And as far as the return type goes, TypeScript is also able to give us an error if we return the wrong thing. So we're trying to return a string, and it expects a number because we told TypeScript, hey, this function only returns numbers. We're trying to return a string, and that's a bad thing. So you got to fix that too. So that's how TypeScript's able to keep our code running a lot more smoothly, more reliably. So one more thing I want to look at here, with total, we're not actually having a type annotation here. And we can, most of the time with variables, we can kind of avoid it. And if we mouse over, we'll see that TypeScript inferred that total is a number. And it's able to do that because if we take a look at the function signature right here, left-hand side is a number, right-hand side is a number, And if we take both of those numbers and add them together, the return type is always a number for that. So it knows that total is already a number. So we actually don't need to tell it that it's a number. We could do that, but that's just extra code we don't need because TypeScript already knows. We see a plus sign as developers and know, oh, we're adding things together, so it's probably working with numbers. And so we can just assume that this is a number. And there are actually situations where having type annotation here actually makes it harder to maintain your code. So for example, if we want to have annotations on all these like we do here, and later on we decide that sum should be changed to work on big integers. We change that to big int. We change each of those. Now we also have to go in here and change this to big int as well. And we can ignore these because we have to change those no matter what. As far as the function goes, we have to change all those to big int. However, we change all this back and we get rid of the annotation here. And we change these numbers, we're going to change those to big int. So we change those, and now TypeScript inferred the total is going to be a big integer, and we didn't have to update the actual inside of the function. And so it could actually make your code easier to maintain by avoiding type annotations when they're not necessary. However, if it does make your code easier to read, then definitely put a type annotation there. So that could happen sometimes if the variables or functions are not named as well as they could be. Then you can just add an annotation saying, hey, this is a number. And that way, in a couple lines down, you already know that total is going to be a number because right there it says that it is. So in this case, having an annotation here could kind of just be like documentation for future development of the function. So most of the time, we don't want to have that annotation on variables. We just want to have them here on our function signatures. So I'm also going to delete these annotations here. So we'll delete those. Whoops. And delete that one. So it's pretty obvious what these are. So amount is a number because it's 2 plus 2. And if we're not sure, we can just mouse over it. And as we're coding, we can mouse over and be like, oh, this is big int. Okay, that's all cool. And we would know anyway because that has an n, and we know this is string literal. So for cases like these, it's actually clearer to not include the annotations, and we don't lose anything because TypeScript already calculates it and figures it out for us. So I'm going to fix these really quick before we finish up. These big ints should be numbers again. Change those back. So if there's one takeaway for the entire course, and this is the whole course, not just this video, but the whole course, if there's only one thing that you want to apply and remember, it's going to be this right here, the function signatures. Always include the type annotation on every function or every parameter and the return type. So just doing this is going to do probably 80 to 90% of the heavy lifting of figuring out the types. And if you do this, you're also going to be able to have inference within the function because once you have all the values, all the types here, then TypeScript can easily figure out whatever's going on inside. So that'll make your code on the inside of the function a lot more clearer. And all you really need to do is annotate the signature. So always annotate your signatures on your functions every time, all the time, and always include the return value type. And that'll do it for this video. I do know that this video was a little bit longer than usual and had a lot of information, especially if you're coming from a dynamic language. Having to add these types is definitely something that's foreign if you're coming from, say, Python, for example. However, we're going to be typing them a lot, and it's not really too much extra to add. It's just a colon and an extra word for each thing. So it's not a lot of overhead, and the benefits you get are quite massive, so it's definitely good to have those. Thanks for watching, and I'll see you in the next one. Programs need to make decisions based on various kinds of input. To do this, we can add control flow constructs to make decisions based on the available data. In this video, we'll be taking a look at the most commonly used constructs. We'll start with the most basic and probably the one you'll be using most of the time, the if statement. If statements evaluate a Boolean expression, and if the result is true, one code path is taken, and if the result is false, the other code path is taken. In this image, the A code path will be taken if the Boolean expression evaluates to true, and the B code path will be taken if the expression evaluates to false. It's common to have more than just a single true or false choice. For these situations, we can extend the if statement by including else if. Else if allows us to add any number of additional Boolean expressions, which allows selecting between more than two code paths. For example, maybe we have some code that determines what color of candy gets chosen for an order online. Else if allows us to evaluate multiple Boolean expressions to choose the correct path to pick the appropriate candy color. When using else if, the entire statement will be immediately evaluated to true once one of the expressions evaluates to true. This means that the expressions evaluate from top to bottom until one of them is true. Another commonly used control flow statement is the switch statement. Switches only check for equality, so you're not able to use any complex Boolean expressions as you would with an else if. If statements can be used to check for equality also, but what makes switch different is it allows us to provide a list of possible things to check. So instead of writing out if with else if multiple times, we can instead use a switch with a list. So the code for a switch ends up being a little bit cleaner and easier to work with. Each item in the list is called a case, and each case performs an equality check. As an example, we could have something like a coupon code. We can check that coupon code against a list of known codes with a switch to see if the discount should be applied to an order. Control flow structures like if and switch statements provide essential mechanisms for directing the flow of a program based on different conditions. Switch statements allow for efficient branching based on multiple possible values, while if statements offer greater flexibility by evaluating conditional expressions. That'll do it for this video. I'll see you in the next one. In this demo, we're going to be taking a look at the if-else control flow statement. We'll start by opening up the demo folder. We'll go down to if-else and open up ifelse.ts. So we're going to start with something easy. So we're just going to have an answer. It's going to be 2 plus 2. We'll assert that the answer is 4. That way we can confirm our if statements that we'll be writing. So now we're going to make an if statement. So when we have an if, we need to have the keyword if followed by parentheses. And within this set of parentheses, we put our Boolean expression or function calls or anything that evaluates to true or false. So I'm going to check to see if the answer is greater than 4. And if it is, then we're going to do something. In this case, I'm just going to log some information to the terminal. So I'm just going to log greater than 4. And we need to have quotes for that. And that's all we have for a basic if statement. So there's nothing really complicated going on. We just have the keyword, parentheses, Boolean expression, and then the code that you want to run if that is actually true. Next, we can have else. So I'm going to check to see if the answer is equal to 4. Remember, always use 3 equals to check for equality. And if it is equal to 4, we're going to have a log. We're just going to say equals 4. Now, if we want to do something if the answer is not equal to 4, because right now this will only execute if it is equal to 4. But if we want something to execute when it's not equal to 4, we use else. We create a new block with the curly braces, and then we can just do another log. I'm just going to do not 4. And so just like the if, we just start with an if, and we can ignore the else. And if this is true, then we're going to get this printed. And then if this is false, so if the answer is not equal to 4, then this is going to run instead. So that's going to go away, and we'll just have the exclamation point 4 get logged to the console. Next, we have else if. So I'm just going to copy this whole block. So we'll say if the answer is less than 4, then I'll log less than 4. We can have else if the answer is greater than 4. So we're kind of combining the else and the if together. We can have greater than 4, and this would be else. So this will say equal to 4. So with else if, first we start with if. So if the answer is less than 4, then this will print out right here. And if this answer is not less than 4, so if this evaluates to false, then we're going to check this next one right here. So if the answer is less than 4, then we'll evaluate this right here, and that'll print. And if the answer is not less than 4, it's not greater than 4, then that would only mean that it's equal to 4. So then we'll print this out. So you can have any number of else ifs that we want. And so if we wanted to have more, we just copy and paste those. So we can have as many as we want. In this case, it really doesn't make a difference because the answer can only be one of these 3. However, in situations where it's more than just dealing with numbers and we have multiple conditions, then you might have 3 or 4 else ifs to check different conditions. So next we're going to combine some compound Boolean expressions. So we'll have an age, and we'll have likes having fun is true. And this will make sense in a sec. So if the age is less than or equal to 12, so if they're not a teenager and they like having fun, which most kids do, then we're going to just go play at the park because that's fun. So we're going to have an else if. So if the age is greater than 12, so they're going to be a teenager now or older, and they don't like to have fun because teenagers are always bored all the time, then they're just going to be bored. Too bad. They got to deal with it. And anything else, then we're going to work on hobbies. So this is just some imaginary code that you can put there. It really doesn't make a difference what's inside the code here. What matters is these blocks here and that they're properly constructed to get the results that you want. So in the first one, they're less than or equal to 12, so they're still like a kid. And they also like having fun. Kids like having fun, so they go play at the park. And if for some reason that the age is greater than 12, like they're a teenager, or maybe they just don't like having fun, then they're just going to have to be bored. That's too bad. And if the person is over 12 years old and they do like to have fun, then that's when we're going to work on hobbies. So when we do have these ifs, else ifs, and else, we do kind of have to evaluate each one in our head and kind of walk through the steps to make sure that our else actually does the thing that we want it to do. Because it is entirely possible when you're constructing these if and else if statements that this else does something that you don't want it to do. For example, there may be something in here and you actually wanted that up here, but the only way that we know what this is doing is by implication, because we have to read each if and each else if to see which one what they actually are evaluating. So that's something we need to be aware of, and you want to keep these as simplified as possible. That way we don't have to read too much code in order to determine what the else is actually doing. Now we're going to be taking a look at another example that's more complicated, and I'll be showing you how to make it a little more simplified. That way it's easier to read, and we'll be doing that in the next video. I'll see you there. In this demo, we're going to be continuing our if-else statement exercise by simplifying a complicated if-else statement. So if your demo file is not already open, we're under the demo folder. Go to if-else and open up ifelse.ts. Scroll down here to the bottom. So we're going to take something a little more complicated, because before all we had was two pieces of data and we just have a few else ifs and else ifs. So now we're going to add something that's a little more complex. So I'm going to copy in some code. You can pause the video and type that all in. So this is going to be evaluating whether or not a person is approved to work overtime at a job. So maybe some kind of employee hourly scheduling system or something. I'm going to put the whole thing into a function. It's going to call it approve work. And it has to decide whether or not this person is approved to work overtime. So I'm going to do it the bad way first. So put everything into one giant if statement. So we're going to have if the person has the skills to do the job, because maybe they're asking for overtime and maybe we have hours available, but it's in a different department. So we have to check to see whether or not they're able to work in that department. We're also going to check to see if it's Tuesday, because Tuesday is going to be our heavy work day. So that's a day that we normally would approve overtime. We also need to check whether to see if the hours worked is actually over 8, because we're not going to give them overtime hours if they haven't actually worked 8 hours yet. And we're going to check to make sure their total overtime hours is less than 1, because we don't want to work anyone more than 1 hour of overtime, because we want to make sure that they have plenty of rest. That way they're sharp and ready to go the next day. We also need an or right here at the end. And for the or, we're going to check to see if it's a holiday season. So as a holiday season, we kind of throw all that out the window and we just let them work anyway, because we need people here to help make sure the business is running. So this is our expression, and I'll make our little code block. So this will be approve work. And if something doesn't evaluate, if that whole statement doesn't evaluate to true, then else will be go home. So they have to go home because we don't have any hours available for that person to work. So if we actually try to read this, which I'm going to try, but it's pretty difficult. So with this, we have a lot going on here. The only really thing that's kind of standing out to me is this and here. So we do know that this has to evaluate to true, and whatever this thing is also has to be true. And that has to be true as well, because we use Boolean and. So this is something that this part is not that bad. But this thing right here, there's a lot happening. So we're checking to see if it's Tuesday. And if it's not Tuesday, because we're using or. So if it's not Tuesday, so maybe it's Wednesday, we have to check this right here. And on this one, we're making sure their hours worked is greater than 8 because they have to work at least 8 hours before they start qualifying for overtime. We also make sure that their overtime is less than 1 hour. In our case, I believe that is true. So because our overtime is currently 0.5. So we could work overtime theoretically. And if this whole thing right here, I believe that whole thing is false, then maybe if it's a holiday season, if that's true, then that whole part just kind of goes out. So we have the skills is true and holiday season is true. Then it would be approved. That might be how it works. I'm not exactly sure. I'm not going to dive into the details of this because this is just awful code. And we're going to rewrite this to be something that's a lot easier to read and work with and follow. So for now, we're just going to leave that there. And we're going to write a new function. And we're going to take the same, it's going to be evaluated the same exact thing, except we're going to actually be able to read it and make changes to it later because it'll be simple to read. So we're making a new function. We'll call it approve more work. And so what we're going to do first, if we look at this one up here, the first thing we did is we checked to see if they have the skills. So we're going to do that. So if the person doesn't have the skills, so we has the skills, then we're going to do what's called an early return. So this will be go home. So an early return is just going to bail out of the function immediately, because if the person doesn't have the skills, so if they Boolean not, if they don't have the skills, then they can't work overtime no matter what. So there's no point in even checking anything else. So they can just go home. So we've taken this has the skills variable out of the equation. Next, we're going to see if they can actually work overtime. So if they do have the skills, we'll see if they can work overtime. We check to see if their hours worked is greater than 8. And our total overtime accrued so far is less than 1 hour. And we're also going to check that. So if they cannot work overtime, then we're going to do the same exact thing. Then we can return. So they're going to have to go home. So we've taken this hours worked part so that's just dealing with the time and how many hours they've worked and how many overtime hours they've accrued. We stick that into the can work overtime variable and we check to see if they can work overtime. Because if they've worked more than 8 hours, and that's true, and their total overtime is less than 1, and ours is 0.5, that's going to be true as well. So in our case, we'll have can work overtime is true, and we'll be able to go past this block and keep going. But if this is false, then the same thing that has the skills, we're just going to bail out early, and now there's no point in checking anything else because they're not even able to work overtime, whether or not we even have it. So it doesn't even matter. There's no more to check. So again, we're just trying to take this out of the equation completely. So now all that's left is we have the days and the holiday season. So if it's a holiday season, or it's Tuesday, because Tuesday is our heavy day, then we're going to approve work. Otherwise, they're going to have to go home. So this has been greatly simplified. We have everything. Let me take this out a little bit. Take those comments out so we can see everything. So we've converted whatever this is, we've converted that into something that's a much more readable using early returns. So we just have the has the skills section right here. We have the can work overtime section here, and we have the part dealing with the actual day of the week or the season right there. So we've broken it up into 3 really simple to follow blocks that we can confidently edit without worrying about anything. Like for example, in the future, if we want to change the total overtime, maybe it goes from 1 hour to 2 hours, we can just go straight here, change that to a 2, and now everything still works and we don't even have to sweat it. Like we don't have to worry about, oh, did we get the right spot, or is this in the right thing, or maybe there's a specific reason this is right here instead of being on this side. We don't know. But here, everything is really clear. Now we can take this even further. Since we've already split these up into individual blocks like this, what we can do is take these blocks and place them into functions. So I'll start with this can work overtime one right here. We're going to create a function for that. So we scroll down. We'll make a function called as overtime hours. Then we'll have the hours worked and total overtime. And that needs to return a Boolean. And so what we're going to do, we're just going to pick this line, we're going to stick it in here, and then we just return it. Return can work overtime. I'm going to change this has hours. The return has hours. We're just taking that logic and we've encapsulated it within a function. And we have to supply the hours worked and total overtime, which is fine. We return a Boolean because we just want to know if it's true or false. We want to know whether or not they have overtime hours. So if we take that function, we can now use it right here. We're going to change that to as overtime hours of the hours worked and the total overtime. And so now we've taken that logic and we've placed it in an individual function. And so we can kind of ignore this logic altogether when we're reading this function. It reads a lot easier. And we do the same thing for this holiday season part. We'll do that as well. We're going to change it. We're going to make a new function called isBusyDay. We're going to have the day as a string and holiday season, Boolean. And again, it's going to return a Boolean. And if we we're just going to write from scratch. So we're going to return holiday season, or if the day is equal to Tuesday. And we also need to go change the way the day is handled. So right now the day is just whether or not it's true. We're going to change that to a string. So we'll just say today is Tuesday. And we'll change that here as well. So this will be day is equal to Tuesday. And now in here, instead of having this if holiday season or if Tuesday thing, what we can do is we can have if it's not a busy day, then we can return. And again, this will be go home because it's early. Otherwise, we'll approve the work. So we've simplified this function even further. So now if we go to approve more work, first thing we do is we check to see if they have the skills. And if not, they go home. And if they don't have overtime hours, then they go home. And if it's not a busy day, then they go home. Now, this has multiple benefits. The first one is this function just reads like English. You don't even have to really understand how the programming works to see what's exactly happening here. And if we want to go edit this, like let's say we want to change what days count as busy days, we just go down to this isBusyDay function. In VS Code, we can hit F12 to jump straight to it. So I'm just going to hit F12. And it jumps straight to that function, and then we can make any changes to define what a busy day actually is. So we've moved all that logic into individual units, which allows us to easily change them. And the same goes for overtime hours. If we want to change hours worked, maybe let's change that to 7, maybe change that to 2. Everything else just automatically works. You don't even have to think about it, and it's all nice and clean. So these are acting as filters. So the early returns are acting as a filter. So we're filtering 3 times, and if our code gets to this point here on the bottom, that means is approved. And we would easily be able to add additional conditions here. Like perhaps maybe you want to add a monthly maximum so we can check for monthly max. And maybe you don't want to approve it if the employee always shows up late. So we have another check for no late employees. So we don't want to give them overtime because they're always showing up late and causing overtime to happen. So we don't want to reward them with extra pay. And so this is just one way that we can simplify Boolean expressions and make our code a lot more readable using them. So we definitely avoid doing this. This is bad. So we don't want to do this one. Let's see, that's green, we want red. We don't want to do that one. And instead, we want to do this right here, where we make everything nice and easy to read. It flows really well, and it's really easy to modify later. And that'll do it for this video. I'll see you in the next one. In this demo, we're going to be working with the switch statement. We'll open up our demo folder, scroll down here to our switch folder, and open up switch.ts. So to create a switch, we need to first have some data to switch on. So we'll create a number. And to make this number, we're going to actually use the parseInt function. And we're doing that because if we just type in 10, then TypeScript will know that some number is always 10. And if we try to switch on it, it's actually going to give us an error saying, hey, you can't even switch on that because there's no point because it's always 10. So we use parseInts that will force this to run at runtime instead of compile time. And then we won't get any errors on TypeScript side because it doesn't know that this is always going to be 10 because it could be anything. We're going to do the same thing for the string. We're going to make a sample. And we're going to use a string template literal. That way TypeScript can't figure out it's always going to be sample. All right, so now to create a switch, we use the switch keyword. We have some parentheses, and then we put in the thing we want to switch on. Now, when we have a switch, we need to provide a list of possible things that the sum string should be equal to. And to create the list, we use the word case, and the case will be for each possibility we're checking. So we can check, for example, tests, and then we have a colon, and then your code here. So your code's going to go here. Once you're done with your code for that particular case, we're going to break. And we can do the same thing for, we can have sample, code goes here, and then break. And we'll do another case, let's say A, then your code goes there, and then you break. And so this is how a switch works and how we generate the list of possibilities. We have our switch keyword, the thing we're trying to switch on, and then each possibility we want to check for. Now I'm going to rewrite this using an if-else block. That way you can see the equivalent code. Because you can use either one. It's just kind of a preference or a readability thing. But whichever makes your code more clear for that particular situation is the one you should be using. So we're going to do the same thing with if. So we have if some string, and we'll keep the switch block in view. So if some string is equal to test, then we'll just rename this will be branch A, branch B, and this can be C. Change that to a C. So some string is equal to test, and we're going to do A. Else if some string is equal to sample, then we do B. Else if some string is equal to C, and that's going to be branch C. Zoom out. So these two here are exactly the same. If you have a switch, you can do it like that. If you want to check to see if some string is equal to test or sample or the letter C, then this is how we can do it with a switch. And if we want to do the same exact thing with the if and the else ifs, this is how you do it with ifs and else ifs. Now, it's kind of just like a preference because both of these are really readable. With switch, we can just provide the list, and that seems pretty clean to me. We just have to remember to include breaks. And with the if, that's also fairly clean. The only issue with the if is we always have to have these equality symbols here, and the switch is just doing that automatically for us. So as far as I'm concerned, this is mostly just a preference thing for this particular situation. Now, we're going to switch on the number now. So zoom back in. We'll switch on some number. So case 1, again, we have some code. We break. Case 2, break. Now, what happens in the situation where we want to always run some code if we don't match these cases, we can use a default. And when we have defaults, this will always be executed if the case doesn't match. So if we have some number, and we'll just set it, make a copy right here. So if we set some number and we change that to 3, that's going to execute our switch. It's going to check some number. It's going to check 1, and it's going to see that 3 is not 1. So that's not going to go. I have 2, that's not going to execute. And so since it's not 1 and it's not 2, it's going to execute the default instead. So this is kind of like the else on an if else. And we're going to write this as an if else block too, just so we can see how it looks. So we have if some number is equal to 1, and this will be branch A, this will be branch B, and this will be branch C. So if some number is equal to 1, we have A. Else if some number is equal to 2, then we have B. Otherwise, we have C. So just like with the strings, these are equivalent. So next, we're going to see what happens if we don't include the break statement. So we'll have a switch on some number again. And we can have case 1. We can actually duplicate this. So we can have 1, 2, 3, 4, and 5. And on 5, we'll break. So we actually don't even need to include code. So this is totally valid. So we can have code, for example, right here. We can put our code here. Now what's happening here is if some number is 1, and we'll do that for demonstration purposes. So if we change this to 1, what's going to happen is we'll go to this switch. It's going to check to see case 1, and it's going to say, oh, this is equal to 1. All right. And now what's going to happen, there's no code here. So it's still going to execute though, and it's going to go down to case 2. See that there's no code. It's going to keep going. No code, keep going all the way down until it hits this break. So the break is an indication that we need to get out of this switch. We're going to exit out of the switch as soon as we hit break. Now this behavior is called fall through because we have number 1 and then we fall through each case, executing all the code in every single one until we hit break. What that means is we can have code right here. So we can have code here, we can have code there, we can have code anywhere we want. And sometimes we can optionally not have code. So if we have 2, for example, we change that to 2, then case 1's not going to execute, but 2 will execute and there's nothing here. And then 3 will execute and then we do have some code, which will again be ran. And then 4 will fall through, and then we'll go to 5 and execute more code. So this behavior, depending on how you look at it and what you're working on, may be something you really don't want to do because it's really confusing sometimes. Or other times it may be something that's really beneficial to use because it makes things more clear. It just really depends on the situation. And so just like the other examples, we're going to use an if-else block just to see how it looks, the equivalent if-else. So we're going to have if some number is, let's say this is going to be greater than or equal to 1. And if some number is less than or equal to 5, then code. So that's assuming if it's just like this with no code. And as we add different code in between each one of these cases, then this if block will become more and more complex. And that's really all there is to the switch statement. There's just always include the breaks whenever you don't want to fall through. And if you do want to fall through, then you just don't include a break. For the most part, it's a good idea to almost always include break, like in this first example, where we have break on every single one, because that's just going to be a lot more predictable behavior when you run your code. And it's a lot easier to avoid bugs if you don't have fall through. So for the most part, just include the breaks and kind of save yourself some trouble from diagnosing bugs later. And that'll do it for our demo on the switch statements. I'll see you in the next one. In this demo, we're going to be finishing up our control flow with the ternary operator. We'll open up the demo folder and go down to ternary, open up ternary.ts. And so what a ternary operator is essentially an if-else block put together on a single line using a very concise formatting. So what we'll do is we'll start with the variable name age. And this will be, for example, like let's say we have a cash register software, and we want to indicate whether or not someone's allowed to make a purchase based on their age. And this particular item requires them to be at least 18 or over. So we'll have const message, and this message will be displayed to the cashier when they try to make the purchase. So if the age is greater than or equal to 18, and here's the ternary part, we have the question mark, and then we have allow. So we'll allow the purchase if they're greater than or equal to 18 years old. And if they're not greater than or equal to 18 years old, then we'll deny the purchase. Now, the way this works with a ternary, we have a Boolean expression. The Boolean expression is right there, followed by a question mark. What we're going to do if that expression evaluates to true, then a colon, and then what we're going to do if the expression evaluates to false. And that's essentially how it works. So we have Boolean expression in my pen. We have a Boolean expression, question mark, what we do when it's true, colon, and what we do when it's false. So in this case, age is 18, and this is going to evaluate to true because that's greater than or equal to 18. And that means this allow is going to go right here. If we change the age to, for example, we change that to 16, then this is going to evaluate to false. And that means this part of the ternary right here is going to be placed here in message. Let's just add an assertion. That way we make sure we have the correct data. So we'll do assert.equal age, and this is going to be deny because we changed the age to 16. I want to run this really quick. So we're going to have, we'll execute this, and this will be the ternary exercise, ternary. And so we do get an error. So this should be deny, actual is 16. Oh, this should be message, not age. There we go. Run it again. All right, so that checks out. So with ternary, it's really easy to make this confusing because all we have is just this question mark and then a colon. That's the only real indications that anything's happening at all on this line. And so my preference is to just use if and else in almost every case, unless it's super simple, just like this one thing, really, really small thing. We're not doing anything crazy in the true case, and there's nothing going on in the false case either. So if you're just assigning some data like this, then that's fine, but I wouldn't recommend nesting any ternary operations. Like for example, if we do this just for demonstration, I wouldn't actually want to do this in real code. So it's C and D. We'll just do like 1, 2, 3, 4. So we can actually nest the ternaries as well. So we can have that one. So we can do this, and then this, and then finally at the end is true. So this whole thing is going to evaluate to a Boolean. This will be a Boolean, and there's something happening here. I don't know what's happening because I just made this up right now. But as soon as you nest ternaries, and this is only nested one level, if you have multiple ternaries, then it's going to be even more problematic and difficult to read. So avoid this at all costs. Like, don't do that. Just make an if-else. It's much clearer to read and easier to work with. But if you just have something simple like this, where you just want to assign a string or get a quick value, then ternary is probably the more succinct way to do so. So this finishes up our video on ternary and our control flow operations in general. In the next video, we're going to be taking a look at structuring our data, and I'll see you there. Effective data organization is vital when writing computer programs, as it enhances code clarity and facilitates efficient data manipulation. Logically structured data and organized data enables programmers to easily access and update information, which makes it easier to write and update programs. So we already know that we need to use variables for storing and managing data. After all, that's how TypeScript is able to access data in memory. This is fine when working with a few pieces of data localized to a single function or two. However, we need something better as the amount of data grows. All of this data here is only 9 pieces of information, but already it's all over the place and we have to deal with it. To organize all this data, we can use objects. Just like logic uses functions as the fundamental unit of group-to-group code, objects are the fundamental unit to group data. Objects can contain any amount and any kind of data. The data is grouped together using single variable names with a curly brace. Since all of this data is assigned to a single variable, we're able to access it just like any other variable we have worked with so far. In addition to being able to access the object itself, we can also access individual pieces of data within the object. Each piece of data is called a property and can be accessed using dot notation. We provide the name for the object and then the name of the property. It's also possible and common to nest multiple objects together. You can nest objects to any arbitrary depth, and to access nested objects, we use dot notation again, and we just add additional dots for each object we're trying to access. If we assigned a single variable to each piece of data in a program, then adding or removing data would force us to make changes across large parts of our code base, which isn't ideal. Instead, we have objects to help us group things together, which makes it easier to add and remove data in our programs. In this demo, we're going to be taking a look at type aliases. We're going to open the demo folder and we're going to scroll down to type alias and open up typealias.ts. So in the most simplest form, which is the only form we'll be covering in this video, a type alias is just providing another name for something that already exists. And to create a type alias, we're going to use the word type followed by the name we want to give it. So in this case, I'm going to create a type called person name, and we're going to set that to a string. And so what we're doing, we're creating a type alias with the word type. We're making a new one called person name, and we're telling TypeScript that anywhere we see person name, that it's going to be a string no matter what. And so what this allows us to do is substitute these two for each other. So anywhere that requires a string, we'll be able to use a person name, and anywhere that requires a person name, we'll be able to use a string. So as far as TypeScript is concerned, person name is a string. There's no checking to make sure that something special with person name, like it doesn't check for capitalization or nothing special at all. It's just a string. Let's create a few variables that actually use this. So we have my name. We're going to say it's a person name. And I'm going to type my name in. You can put your name for yours. I have also my name. We're going to set that one to be a string. So now if I put my mouse over also my name, TypeScript says it's a string because we told it it's a string. This right here, double quotes, is a string, so everything's cool. Now here we have person name, and we have the double quote, so that's a string, and we know that's fine because they're equivalent. When we mouse over my name, TypeScript says that it's a string because person name is purely for us as developers, so we can document our code. And even if we put our mouse over person name, it tells us that the type person name is a string. So it's an actual string. There's nothing special happening at all with person name. It's strictly for developer documentation to create code that is more self-documenting. Now, how can we create more self-documenting code? I'm going to show you right now. So we're going to write 2 functions. One is going to be a bad function, and we're going to have a good one as well. I want to write a function called print, and the parameter is going to be thing, and that's going to be a string. And we're going to console.log. We're going to make a template literal. We have name is thing. So this would be something that's supposed to provide a message to a user or just log what the person's name is. So in actual code, like a big project, and you have thousands of functions, you're not going to see the body of this function. So we can collapse the code with this little arrow right here. We just click that. And so all we're going to really see when we're writing code, 1,000 lines away, we're going to see a function called print. It prints things, so it must just print anything. Maybe it just logs to the console and does some other work. We don't know. And so this is our only real entry point into understanding what this function does, because if we have to go into the body and actually read what it does, then that means we already failed. So that would mean that this function name is not named correctly, because it just says, who knows, it can print anything. Saying is definitely going to be anything. Who knows what that is? And at the very least, we know it's a string. So we can call the function, but it might not do what we think it does. And so let's actually call this. So we can just do print, and we're going to print a house, because why not? And so if we run this, pop it to a terminal, we're going to run type alias. And so it prints name is a house. So that doesn't really make too much sense, unless your name is a house, but it's probably not. And so this is a bad function. Now, if we rewrite this function using better naming and our type alias, and this is going to become a lot more clear. So I'm going to expand this because we're going to copy some code. So we're going to make a new function. This will be the good one. So this is going to be function, let's see, print name. And then we're going to have name is going to be person name. And then we can just copy that function right out, or copy the console.log. So this is going to be name is name. So now if we collapse this function here, we can see we have a function named print name, and we must supply a name, and that name has to be a person name. And if we don't know what a person name is, then we can just mouse over that and we can see, oh, it's a string. That's cool. So we know it's going to do something to do with printing people's names probably, because everything's named properly. We're using a type alias instead of a string. As a string, maybe the name could be a name of an address. It could be a name of a business. It could be name of a fruit. We don't know, because anything could have names, and everything does have names. But we know for sure it needs to be a person name. So we're going to try it again. We're going to do print name, and now we have a name. So I'm just going to put my name variable. And we run it again, and now we have name as a house, which is our bad function, and then we have name as Jayson. So this is how type aliases, if used properly, can provide self-documenting code like this, because this is much more obvious what it's doing. And like I mentioned, in a large program, you're not really going to be able to look into the body to see what it does, because you're not going to have time to do it, or it's going to be a really long function, and you just want to build things and get stuff done. So creating type aliases and using them in this way allows all those things to happen. And that'll do it for this video on type aliases. I'll see you in the next one, where we're going to be talking about object types. In this demo, we're going to be taking a look at object types. We'll open up the demo folder, scroll down to objects, and open up objects.ts. So this will be similar to our type aliases, except now we're going to be creating a type alias and defining what the type actually looks like, instead of just using a pre-existing type like we did before. So to create an object type, we start with the word type like we did before. I'm going to make a coordinate. So it'll be on a two-dimensional plane. So like if you're plotting lines or anything, we'll have coordinates. And we set equal like we did before with the type alias and the string. Now we're going to use curly braces to create an object type. We're going to want to end that with semicolon as well. Now within these curly braces, we're going to define all the properties for this type. And so a coordinate on a 2D coordinate plane has an X and a Y coordinate, and those are both numbers. So we're going to have an X colon, and that'll be the name of the property. And we're going to specify the type for that property. And so we also have the Y coordinate, that's going to be a number. And we can put anything in here. We can put names, and those can be strings. We can put other types. We can even make type aliases. Type A equals number. And then we can say B is an A. So all that matters is that we have these properties. These are the property names we're going to use for our coordinate. And then each of these properties must have a type. And that's just really just two components. So we're going to delete some of that stuff that I just made, because we just need the X and the Y. Now to create a new coordinate, I'm going to make an origin. So that'll be at 0, 0. We use a colon coordinate, and then we're going to use curly braces, semicolon at the end, and we'll set the x to 0 and the y 0. So one thing I do want to note, when you create the type alias here, we end each property with a semicolon. When we create an actual instance of the object where we set the data, we use commas at the end. So that's just like a slight difference, but it is important. So if we want to access an individual property within this coordinate, we need to use dot notation. So I'm going to call this x position, and we're going to access origin.x. And so that'll grab the x. And even when we hit the dot, we can see right away, we get this pop-up here, and it tells us what's available within origin. And we know that origin is defined right up here, and it has the x and the y. And TypeScript went and looked at this type, and it pulled these out for us. So it makes it really easy to discover what's available within an existing type. And it even tells us that it's a property, and it even tells us that it's a number. So we have all the information we need right away to start using this correctly. So I just want to access the x. And if we want to get the y position, we can just pull the y position out. And we don't actually have to copy it out with constants like I'm doing here. You can just use origin.y or origin.x wherever you want. It's really just a matter of preference and how deep you have to go. Like if you have to go really deep like this, then it might be better to make a constant. But if you just have this one thing here, then it's probably better to just use origin.x and y directly. I'm going to add an assertion here just for clarity, and we can run it later. So x position is going to be 0. And then y position will also be 0. Now we can also modify these. So this is a constant. So we're going to make a new coordinate. I'm going to use let. That's going to be a coordinate. And we'll set this one to be 1 at 1. Now we can modify this by doing coord.x, and we'll change that to 20. Then we can change the y part of the coordinate to 10. And so now this has been updated. So we started with a coordinate with position 1, 1 right here. So the x is 1, the y is 1. And we changed it to have an x position of 20 and a y position of 10. We can verify this with an assertion. So we can do assert.deep equal. We're using deep equal so it compares everything within the type. So we'll start with our coordinate, and that's going to be equal to x20, y10. Now you may have noticed I'm comparing this coordinate here with just these curly braces, and I didn't specify coordinate. So I've been specifying coordinate each time. So here we have the origin, and I'm telling TypeScript that it's a coordinate, and here for the core, I'm telling it's a coordinate. But here I'm not doing anything. I'm just putting some curly braces, and then that's that. And there's actually a really good reason for that. And the reason I'm allowed to do that is because just like with the type alias of string, TypeScript only cares what exists within this coordinate type. So I can have an x and a y just by itself. So if I go, I'll make another one. I'll just say this will be 3, 3. So I'll just call it 3, 3. If I go x20, y10. Now this is going to be usable anywhere that a coordinate is also usable, because all that matters is that I have an x field that's a number and a y field that's a number, because that's all that exists on the coordinate up here. There's an x property that's a number and a y property that's a number. And so TypeScript will look at the types and just make sure that these properties exist. We don't actually have to specify that it's a coordinate, because again, since it is a type alias, it's just for documentation for us as developers. So I want to do another function, just like we have the type alias. So we're going to have print coordinate, and we'll have core, and that's a coordinate. And we'll do a console.log, and we'll just log core.x and core.y. Nothing fancy. And we're going to print chord, and we'll supply our chord, and that'll work. And we can also do it with we'll do x is 5 and y is 10. And that'll work too. And see, TypeScript's not complaining about it, it's fine. And if we mouse over 3, 3, we'll see that it's an x number, y number. If we mouse over this chord, it tells us it's a coordinate because it's an object type. So if we mouse over coordinate itself, we have x number, y number. So this is the part that TypeScript is concerned with, is just the shape of the data. And if you look here, we have X number, Y number, and that's exactly the same X number, Y number. So TypeScript looks at both of these here, this one here, and it looks at this one here, and it determines that both these types are of the same type. So if we run this, we're going to get the coordinates printed out for both our chord up here, which is 2010, and we'll also get 510. So we'll just confirm that. So we should get 2010 and then 510. So there we go, 2010 and then 510. And so we use this print chord function with two different sets of data, one using a type alias and one just using curly braces. Now we can have type aliases within type aliases. And so I'm going to make a location, a new type, give me an object type again, just like we did with the coordinate. And within location, it's going to also have a coordinate. So the coordinate is going to be like a location on the map. And the name will have person name, and we'll just use that type. That's the one we did in the last video. That'll be a string. So this would be the location of a person because we have a coordinate and we have their name. And so we'll say someone's home, and we'll say that their coordinate is at x0 and y0. And we'll say the name of this location is home. And now to access, since we have nested objects, to access coordinates from home, we can say, or let's just update it. So we'll change the coordinate in the home. We'll go home.chord to access the chord property. Then we're going to do another dot to access the x property. And we're going to set that to 1. And so now we're able to update the information within this home, and we can access it the same way. So if we just switch this around, if we want to get the y position, we can do home.chord.y. And again, TypeScript is checking this. So as soon as we hit dot, we get access to everything that's available within home. We want the coordinate, and then we want the y position. And there we go. So that's how we can access nested objects. And again, this can go on forever. So we can have keeps autofilling. So we can just have multiple objects depending on how deep you need to go. Obviously, I wouldn't recommend going this deep, but sometimes you can get 3 or 4 levels, in a pretty normal circumstances. And so that'll do it for the object types. So what we do with object types, we assign a shape to the object. TypeScript is able to figure it out. We're able to use curly braces to define the shape of other objects, and TypeScript will determine that they match because coordinate has XY, and this one also has XY, so essentially they're the same. And we're also able to use nested objects and access them using multiple dots. And that'll do it for this video. I'll see you in the next one. In this video, we're going to be taking a look at arrow functions and function expressions. We'll start by opening the demo folder and go to arrow functions and open up arrowfunctions.ts. So a function expression, it's a function that's assigned to a variable. So if we create a sum function, and we can assign it to a variable by using const sum equals function, and we can just take out the name there. And so now this is a function expression, and we can use it just like we would a normal function. So we can sum 1 and 1, and it works just like our regular function we've been doing. We can also create an arrow function. I'm going to copy this one, rename this to arrow sum. Now an arrow function doesn't need the function keyword, and and we're also going to add an arrow here. So that's going to be equals with the greater than symbol to create an arrow. And so that works the same way as our other function expression. So if we do 10 here, we can do 5 and 5. And so here at the top, we have our function expression. And this is our function expression using the arrow syntax. So most of the time when we make function expressions, you're not going to want to use this one because it's just extra typing with the word function. And with this one, we know it's a function because we have parentheses, and we have the arrow here at the end. So that's how we know it's a function. And also, if we take a look at TypeScript, if we mouse over on sum, this should be arrow sum, sorry. It should be arrow sum. If we mouse over sum right here, we'll see that TypeScript automatically converts it to an arrow function on the type signature. So these are completely identical, sum and arrow sum, because they're both function expressions. And we're just going to use arrow syntax from here on out. So this will be the only video where we actually put the word function here for our function expressions. Now, the reason why you'd want to do this at all is because sometimes you'll be writing a function And that function requires an additional function that's passed to it. And that's where function expressions can start coming in handy. It's not required that you use a function expression. You can just use a regular function as well. But it's common to use function expressions for this. So we'll go down here. And we're going to create a calculation function. And what this will do is it's going to take an existing function, use it to calculate a number, and then return the result. So in our function signature, we're going to need to have, it's going to accept one of these functions that has a left-hand side and right-hand side. We need to put this entire thing into the function signature. So we're going to do that now. So this function will just be called calculate. And I'll use fn for short. That just means function. So we need to have a function expression with the parentheses. We have left-hand side, right-hand side. We have our arrow, and that's going to return a number. So now we've placed a function expression here, and to call it, we're going to call calculate, and we're going to put the arrow sum as the function. And so now this calculate function will say we have a result equals fn. We can calculate it with some numbers. We can do 5 and 6, so we'll get 11. We'll do a console.log, and then we'll log the results. So we'll run this real quick. So this can be, we're going to execute demo/arrow functions. And so it went and calculated 11. So what's happening here is we have this calculate function, and it accepts an additional function. Once this function goes in here, then we can call it like we would a normal function. So it's like the fn is just giving like a new name, for example. And so we take that function, we call it, and we call it with 5 and 6, and then we just log the result. Now, the reason this is cool is because we can use this calculate function with any number of functions. So for example, we take arrow sum, we change that, this can be sub for subtraction, and we could do left-hand side minus right-hand side. Now we can calculate sub. And so now we're going to have 5 minus 6, and that's the result of the second calculate function call should be -1. And so there we go. So you may have noticed with our calculate function, we can't actually set what number we want to calculate with. So it has 5 and 6 hard-coded here, which is not that great. So what we need to do is we need to add additional parameters here to the calculate function to actually allow us to calculate other numbers. So what we're going to do is we're going to add some more numbers here, or add some more parameters. So we're going to have left-hand side and right-hand side. And then we're going to change this to left-hand side, right-hand side. We'll add a little bit of space here so we can see what's happening. So here's our function signature. So our first parameter is the function, and then our second and third parameters are the left-hand side and right-hand side that we're going to operate with. And we do need to change this. So if we want to do the arrow sum with 5 and 5, and we can do subtract, we can do 10 minus 3. So that's how we would call it. Now, looking at this function signature is not that great. So even if we do this, it's like, there's a lot going on. It's kind of hard to read. And what we can do instead of having it like this, we can take this whole line out right here, take out this whole line, and we can make a type alias. So I'm going to name this calculation fn. That's going to be this right here. And so I just pulled that out. And now instead of having that long part in the calculate function, we just have fn is a calculation function. And then we can format that. And so now it's much cleaner to read. We have this calculate function. It takes another function, which is a calculation function, and along with a left-hand side and a right-hand side. When we mouse over this, it's much easier to read, and it's a lot clearer too, because we see that this is the fn, this is the calculation function. And if we need to know the exact parameters for the calculation function, then we just take a look at that and we'll see it. It's the left-hand side, right-hand side, and you have the arrow and it returns a number. So with this calculate function, it's probably a good idea to actually return the result. So we want to return the number as well. And so we're going to return our function left-hand side, right-hand side. Now there's additional benefits besides just being able to call it with any arbitrary function that we come up with. We can also do something like logging. Let's say, for example, we'll set the result again. So it'll be function left-hand side, right-hand side. And for some reason, if we want to, let's say it's like a video game, and if you get a certain number, then you win like an extra prize or something, or you get bonus points. So if the result is equal to lucky 7, then we can have additional code that does something. So we'll say you win extra. And otherwise, it just returns the results. And so now we're going to console.log that 2 times. And there we go. So now we're going to have our calculate with our arrow sum. We're going to add 5 and 5 is going to be 10. We're going to calculate with our subtraction expression. That's going to be 10 minus 3, which is 7. And that's actually going to trigger this extra code right here. So we'll run that. So we have 10, and then we have you win extra, and then we get 7. And so that's the main reason why you'd want to send functions to other functions, is because you can wrap it up with additional functionality to do something else in certain circumstances, or allow you to extend your program, and you won't be limited to just this logic here. We have sub, we can also do another one. For example, we can divide, we can just do a division, and we can put any logic we want into these function expressions, along with any logic that we want in the calculate function, and get full control and a lot of maintainability with our code by using the function expressions and the arrow functions. So I know I covered a lot in this video, and it is a little abstract, especially if you haven't done much JavaScript programming, because JavaScript heavily uses functions to functions and function expressions. So if you're not coming from JavaScript, then this may be kind of weird. But if you don't fully understand how it works, then definitely check out the exercises and try to get through them. But for the most part, this is something we will make a lot of use of. And so if you don't fully understand it, then as we do it more and more, then it should start to become more and more clear as you get additional practice. That'll do it for this video. I'll see you in the next one. Much of programming work needs to handle large amounts of similar data. Things like user account names, lists of URLs, or lessons in a TypeScript course. To manage this, we can use arrays. Our data organization techniques so far have focused only on individual chunks of data. We have variables, which can be any single thing, and we have objects, which group multiple parts into one bigger single thing. These can get us pretty far in terms of data management, but at some point we need to manage multiple variables or multiple objects. And multiple can mean 2 things, 2,000 things, 2 million, or even more. To manage multiple pieces of data, we can use arrays. Arrays allow us to take any kind of data and manage multiple of that data. This is really important because many circumstances require management of many pieces of similar data. When we put individual units of data into an array, that data is then called an element. So arrays contain elements. We can put anything into an array. For example, we can create an array of numbers. Objects count as anything too, so we could put multiple objects into arrays as well. However, we shouldn't mix and match things within an array. If we were to put different data types into a single array, then we would need to write extra code to handle each of those different data types. And each time we place some new type into the array, we would need even more code. And this will cause the code to grow increasingly complicated and make it difficult to work with. So to prevent this, all elements in an array should have something in common. This makes it easier to write code because we can operate only on the common parts and then ignore the differences between the elements. Let's take a look at an example of operating on array elements. Let's say we wanted to add all the numbers in an array. If we only have the numbers in an array, then that's no problem. We can add all the numbers together and get a result. Now, if we start mixing different data types in an array and try to add them together, we may not get a result that makes any sense, or maybe the program crashes. Either way, this isn't what we want, and we don't want to have to write additional code to handle these situations. This is why we prefer to always use the same type within an array. Arrays don't always have to contain data. They can be empty, and it's actually pretty common to start with an empty array and then add elements later when we need them. Arrays also have a lot of built-in functionality. Most common functions are push and pop. When we want to add an element to an array, we can push data onto the array. And we want to remove an element from an array, we can pop the element off the array. There are many more built-in functions that include slicing arrays into pieces and merging multiple arrays together. We won't be covering all those in this course, but you can get detailed information from the documentation, which will be linked in the demo files. And that'll do it for the overview on arrays. I'll see you in the next video. In this demo, we're going to be working with arrays. To get started, we're going to open up the demo folder and open up arrays folder and then arrays.ts. So what arrays allow us to do is store multiple things in a single variable. And this is different from objects because we'll also be able to store multiple objects in a single variable. So let's start by creating a basic array with numbers. So I'm going to create an array called numbers, and I'm going to set the type annotation to number because that's the type we're going to be storing. And to make it an array, we use square bracket like that. So that's going to make it, this will be just a single number, and this is going to be multiple numbers, an array of numbers. To add numbers to the array, or actually to initially set the numbers within the array, we can set the numbers right here within square brackets. So I'm going to set 1, 2, and 3. And also we can just have this empty. So if we wanted an empty array, we could just set it like that. But I want to start with 1, 2, and 3. We can do the same thing with letters or strings. So we'll have letters. It's going to be an array of strings. And we can do A, B, and C. So as I mentioned before in the previous video, each piece of data within the array is called an element. And the elements start at 0. So it uses an index, and the index always starts at 0. So I'm going to add some comments here so we can kind of see how this works. We have A and B and C. I'm going to zoom in a little bit. So here we have our indexes. So our index A is going to be 0, B is going to be 1, and C is going to be 2. So now that we have our indexes listed, I'm going to show you how to access one of the elements at that index. So if we want to get to letter B, we can access it by taking the letters variable, using the square brackets, and putting the index number. So the index for B is 1, so we're going to put a 1 right there. And that's going to give us the letter B. And we'll do an assertion on that as well. So B is going to be equal to B. And if we want to update the information within this array, we can do that as well. So instead of putting this letters right here on the right side, we're going to stick it over here on the left side. So we can do letters 1, and we're going to change that B. We're going to change that to a Z. So we can do an assertion again. So we can assert that letters 1 is equal to Z. And we can also do a deep equal. We can do a deep equal to check an entire array. We'll make sure letters is equal to A, Z, and C. I'm just going to run this to confirm everything is fine. So we're going to execute our arrays, arrays.ts, and we don't have any errors now. So to access things out of the array, we use this notation here where we select the index, and to set something into the array, we use the same exact syntax, except it's just the position. So if we want to set something, it's going to be on the left side of the equal. And if we want to read something, it's going to be on the right side of the equal sign. Now, I mentioned in the slides that we shouldn't be mixing things. So while we can technically do something like this, where we're mixing the number 1 and this word hello, we can technically do that, but we don't really want to do that. So we're going to try to avoid this. Now, there's going to be situations where you want to do that, but those are going to be few and far between. But when you do need to do it, you'll know you need to do it, and you just understand that it is possible. But for the most part, try to avoid it, because it's going to make your life much easier if you just put one single type per array. We can also create multi-dimensional arrays. So far, we've been creating arrays with a single dimension, and they just go like this, left and right, because we just have one element, next element, just keeps going like that. We can have multiple dimensions, and to do that, we can make one like this. I'm going to call it names. So maybe this is like first name and last name. So to create a multi-dimensional array, first we start with our square brackets right here, and then we have additional square brackets within there. So each element is actually going to be an extra array. So maybe we're going to have, I'll put my name and then last initial, and then we'll just do another one. We'll do Alice. Maybe her last initial is B. And so now we've created a multi-dimensional array. And the way this works is we have our array on the outside, and each element is its own array. So this is a 2-dimensional array, and you can make any dimensional arrays that you need depending on what you're actually using things for. Now, if we want to access things out of a multi-dimensional array, then the syntax is similar to what we've been using. So if we want to access my name, we'll go into the names array. We want the element 0. So this is going to be element 0. So that's going to be 0, and this one is 1. And since it's multidimensional, the Jayson element within that array is 0, and this one is 1. And same thing there. So we have to access, first, we need to access this entire array by itself, and that's going to be 0. And then for my first name, we want to access element 0 of this array. So first we're going to get access name 0, and then name 0 again. It's going to be my first name. We want to access L, so that'll be the L in my name. We're going to be names 0, 1. Then to access B and Alice, it's names 1, 1. Don't want to put the semicolons at the end. I'll just put B2. So when we have multidimensional arrays, accessing it starts looking a little tricky, and the more levels you go, then the more numbers you'll need to access individual elements. So it's sort of like doing a dot notation, except for using the square braces and numbers instead of dots. Next, I'm going to go over a few functions that we can do with arrays. I'm going to start with an empty array. Just going to call it, this will be letters B since we already have letters. And this is going to be actually nums. We'll use numbers. Will be number array, and we're going to start with an empty one. Now this is a const right here, but we can't reassign an array, but we still can edit the array. So what we're going to do is we're going to take nums, and we're going to use .push. And that's going to add something to the end of the array. And since the array is empty, it'll be the first element. So we can push number 10, and we'll do 20 and 30. We'll do 20 and 30. And if we do a deep equal here, we'll do an assertion. And this will be, we'll have nums, and that's going to be equal to 10, 20, and 30. So each time we call .push, going to take this array and just stick this number in there, and then 20 is going to go as the next one, and then 30 will be the final one. And our array will end up looking like this. And if we want to take something off the end, we could do nums.pop. And so that's going to remove this 30 right here. So if we do a deep equal, we can just copy this, and we'll remove the 30. And so pop is going to remove last element, and push is going to append element. Next, I want to show you a splice. So we can splice things too. So if we take nums.splice, that's going to remove an element. So the first argument for this function is the index to start at, and the next argument to this function is the number of elements to remove. So if we splice this array, we're going to end up with 20, because we're going to take element 0, and we're going to start at element 0, and then take one element from element 0, and that's going to leave us with 20 right there. And I just want to confirm by hopping in the terminal and rerunning it. Hopefully we don't have any errors. Everything's good. And so this is how what we can do to remove elements from different locations, because pop only removes the last element. And there's going to be lots of situations where you want to remove maybe the first element or maybe the middle element. And that's when you're going to use splice instead. And again, if you want to remove multiple elements, you're just going to change this 1 to 2 or 3 or however many you need to actually remove. Arrays have a lot of additional functionality, and we may cover some of it throughout the course. However, the main things we'll be using are the splice, pop, and push. And so I just want to emphasize these are going to be your main ones you're using all the time. And we don't want to forget that we can also access individual elements using the brackets here with the index. And we can assign individual elements using the brackets with the index again, just on the left side of the equals. So reading is on the right side and writing is on the left side. That'll do it for our video on arrays. In the next video, we're going to be taking a look at how to work with arrays and objects. I'll see you there. In this video, we're going to be working with arrays and objects. To get started, we're going to open up the demo folder, open up array object, and then arrayObject.ts. So it's not only possible to store strings and numbers in arrays, we can also store complete objects. So to get started, I'm going to make a new object type and call it link. And this will be like a link in a web page. So it's going to need a title and it's going to need a URL. We're going to create a few links. So we're going to have Microsoft. And it's going to have a URL. And then we're going to make another link to TypeScript. So now we're going to put both of these into an array. So we'll make a new array called sites. I'll call them links, actually. We're going to put Microsoft and TypeScript into the array. So if we put a mouse over here, we'll see that we have links, and that's an object, and the object has a title which is a string and a URL, which is a string. At the end here, we see these square brackets, and that indicates that it's an array. So we have an array of these kinds of objects. So to access an individual property within one of these individual objects within this array, we're going to have to work backwards. First, we're going to have to start with the array index. So this is index 0 and index 1. So if we want to get access to the TypeScript URL, so make a new variable called TSURL, we're going to access our links, and we need to access index 1. Then we're going to use dot because index 1 is an object. If we mouse over this, we'll see it is indeed an object. We use dot notation for objects. And now we have access to the title and URL. And that popped up automatically because TypeScript knows that we're dealing with objects. So I just want the URL. And so there we go. So now we have the TSURL, which is a string, and we're good. And that's how you access an object and a property within an object within an array. If we want to edit a property, we can access the array. And let's say we want to change Microsoft. So I didn't capitalize this M, so I'm going to fix that. So we're going to go access the Microsoft, and that's here at element 0. We're going to use dot title, and we're going to set that to Microsoft. Now, even though this is const, it's okay that we're making an update because we're not using an equal sign to reassign the entire array. We're just reassigning something within this array. If we try to do this, where we have links equals new array, that's going to be an error because we can't reassign it, but we can still edit it. And so that's why it's allowing us to do so. So even though we're using objects, we still have access to all the same array functionality like pop and push and splice. That doesn't change. The only thing different is when we work with objects, we use the dot notation to access properties within the objects. But otherwise, the arrays function identically to using it with numbers and strings. And if we had multiple properties and multiple objects nested within these objects, again, we can use dot more stuff and keep using more and more dots to access more and more objects within nested objects. The only real difference is we do have to set the index of the object that we want to access. And that'll do it for the video on objects and arrays. I'll see you in the next one. In this video, we're going to be taking a look at tuples. We'll start by opening the demo folder, scroll down to tuples, and open up tuples.ts. We worked with arrays, and we know that arrays can have a single data type. Tuples differ because tuples are going to allow us to have multiple different data types in a single collection. The trade-off is we're not going to be able to add as many pieces of data that we want to a tuple like we could with an array. So let's hop into an example. We're going to be working with something to deal with books. So we'll have a book title, create some type aliases, and we'll have a year that it was published. Next, we're going to create a tuple type. So we're just going to call it book. And to create a tuple, we're going to use square braces like we're making an array. And then we're going to specify the types that we want to exist in this tuple. I want to have a book title and a publish year for my tuple. Now that we've created this tuple type, we can use it. We'll make a sample book. Use a type annotation. This is going to be sample and 1980. Now, having this type annotation here is pretty important because if we don't have a type annotation, if we just remove it, then TypeScript is going to assume that this is an array, and it's going to try to tell us that this is an array that might have strings or it might have numbers. And that's not what we want. We want a tuple type, and that's tuple type is the one that we created right here. So we're going to have this type annotation. That way TypeScript knows that we're working with this specific tuple type that we created. So with the tuple, we're not able to add additional data to this book. So our tuple type specifies that we have a title here and then publisher next. And so if we try to add additional data here, we try to add, for example, then we're going to get an error. So we have red highlighted. That means we got an error now. And if we try to add a number, that's not going to work. And if we try to take out a number, it's not going to work either. It has to always be the exact pieces of data that we specified in the tuple. Now, this might seem kind of restrictive, but it is actually really useful because whenever we make a tuple type, like we've created right here, we know whenever that we're working with a tuple type, we're always going to have those two pieces of data that we can operate on. We don't have to worry about data missing. We don't have to worry about too much data. It's always going to have these pieces of data nicely packaged into this one little collection. Now, to access data from the tuple, we're going to use the indexing syntax that we've been using with the array. So I'm going to just make an assertion, and we're going to access the book title. So to access the book title, we just use an indexing for field 0. So with our tuple, it's accessed similar to an array. This is going to be index 0, and this will be index 1. So to access the title, we just use index 0, make sure that that is sample. And for index 1, make sure that's 1980. We can also return tuples from functions. I'm going to write a function to return some coordinate. I'm going to return a tuple. So it's going to be an XY coordinate pair. So to create a coordinate pair, we can make a tuple by using the square brace. And then we have number and number. So that could be like an X and a Y. Then we can just return a tuple. Let's say we'll return 3 and 5. So now we can get this coordinate. We'll just use our function. And now if we mouse over, we have this tuple type, which is a number and a number. And we can do an assertion just to make sure that we have the correct data. So we'll assert that our coordinate 0 is equal to 3, and that our coordinate 1 is equal to 5. Now, if you're working a lot with tuples, typing it like this can get a little bit troublesome, and then you might end up with the wrong index. And so what we can do instead of that is a destructuring operation. So to destructure this, what we can do is when we create our variable here with const, we can put the tuple syntax here. Let's say we want to get X and Y, and we'll call our function. So instead of this function placing the coordinate tuple into this variable, when we call this function, it's going to automatically split the tuple. We have our 3 and our 5. And it's going to place the 3 into the X and the 5 into the Y. And it's going to do that automatically. And then we'll be able to access X and Y just like we would with the indexing operation. We can do an assertion again. We can assert that X is equal to 3, and we can assert that Y is equal to 5. So most of the time you'd want to use a destructuring operation with tuples. That way your code is a lot cleaner and easier to read, and plus you don't have to worry about these indexes right here. Now we can also put tuples inside of arrays. So if we create a new array, I'll just call it multi, and we'll use the coordinates. So we're going to set a type annotation. We want to have a tuple, and we want to have an array of them. It'll make the array, and then we can start adding tuples. So we can just call our function to add one, and we can also just type one in. We can have 1, 1. We can have 0, 0, and we'll just do 9, 9 for fun. So now we've created an array of tuples. So here is the type that exists in the array, which is a tuple. And when we add the square braces at the end, that just means we have an array. And so now we have 4 items in our array, and each one is a tuple. So overall, tuples are really useful when you want to return multiple pieces of data from a function because you can just wrap them up in a tuple and you get the type checking, and you can also easily assign the multiple values using a destructuring operation. That'll do it for this video. I'll see you in the next one. There will be many cases where we need to repeat some action multiple times over and over again. This is where repetition comes in. So here we have some code. It could do anything, doesn't matter. And we want it to repeat. So we can tell it to repeat, and it will do whatever we program it to do over and over again in a loop. If we assume that this block of code is responsible for making sure grocery bags are properly filled, then it's just going to repeat forever. And we need some way to make it stop so it doesn't fill up more grocery bags than what we actually want filled. Now, ultimately, there's two things we can do. We can either continue looping forever, or we can exit out of the loop whenever we fill up all the grocery bags that we need. Regardless of our decision, we're going to need some code that can help us actually do that. And this is where a for loop comes in. A for loop provides a way to set up a condition that, once met, will automatically end the loop. So for example, we can set up a condition to stop whenever 4 grocery bags are filled. So it will loop one at a time. So we have 1 item, then 2 items, then 3 items, then 4 items. And once we hit 4 items, which is our maximum here, then the loop will automatically terminate. So we're going to be making use of the for loop extensively in TypeScript because it automatically manages the state of the loop for us. And it's great because we can just write a little bit of code and automatically it's going to end when we tell it to end, instead of us having to track which loop number we're on and making sure every little detail is perfect. The for loop just handles that for us and we don't have to sweat it. And so that's it for our quick primer on the for loop. I'll see you in the next video. In this demo, we're going to be taking a look at for loops. We'll open up the demo folder and scroll down to repetition 4 and open up repetition4.ts. So what a for loop allows us to do is it will loop until a certain condition is met, and it's going to automatically manage that condition. So to create a for loop, we start with the for keyword, and we're going to have an initialization variable. And I'm going to set that to be named I, and we'll start with the value of 1. So this initialization variables, this will only be ran a single time when the for loop first starts. So we're going to set I equal to 1. Next, we have a Boolean expression, which is going to be what we check for on each iteration of the loop. So we have I is less than or equal to 5. So we're going to check every time we loop to see if I is less than or equal to 5. And this third part right here is going to be what we do with the I on every loop. So we're going to use I++ to increment I each time. And within here, we can form whatever code we want multiple times. So I'm just going to log what the actual value is of I. So we have our keyword, and this will be our initialization, and then our Boolean expression, followed by, usually it's going to be increment, but we can use decrement as well, and we'll see an example of that. So I'm going to run this. What we should be getting, we're going to start with 1. So I is going to start off at 1, and then it's going to get checked. Is I less than or equal to 5? It'll be 1 in this case, so that will be true. And then what we're going to do is enter into this loop since it's true. Once this is true, we enter into the loop. And then once the loop completes, this will execute right here. So this executes at the end of the loop. It's going to increment the value of I by 1, and then we're going to check it again. So I will be 2, and 2 is, again, less than or equal to 5. That'll be true, and we'll keep going. So it's going to print 1 to 5 on the terminal, because once I is equal to 5, on the next iteration, I is going to be incremented to 6, then this will evaluate to false, and then we're going to exit out of the loop. So I just want to confirm this by hopping into a terminal. So we'll execute this. This will be repetition 4. And so there we go. So we have 1, 2, 3, 4, and 5. Now we can also go backwards. We can count down. So for example, if we have 4, we're going to let I equals 5. And as long as I is greater than 0, then we're going to subtract 1. So we'll just do a decrement instead. We'll do the same thing. We'll log. So this one's going to count down from 5. I'll just put some spaces here. So in the second loop, we're going to start at 5 and go all the way to 1, and then that loop will complete. And so there we go. So we have a first loop going 1 through 5, and our second loop going from 5 to 1. Now there's going to be many occasions where you'll run into situations that don't need to complete the entire loop. And in that case, we can actually exit early out of the loop. So I'm going to make a new loop. I'm just going to copy this first one we did, paste that down here. And instead of setting I less than or equal to 5, we'll do I is less than or equal to 10,000. And we're going to leave the logging here. And so within this loop, we can check to see if I is equal to 3. It could be any condition. It doesn't really matter. I'm just going to do this for an example. If we use the break keyword, that's going to break out of the loop. So as soon as I is equal to 3, this break will be encountered, and we're going to jump out of the loop immediately. So we're not going to evaluate this expression here. We're not going to check to see if I is less than. As soon as the break happens, we're out of the loop. So we're going to get, in this situation, we're going to have 1, 2, and 3 printed. So let's just confirm that by running the program. Clear the screen. And so there we go. So we have 1, 2, and 3, and it didn't print 10,000 times because we have the break, which stopped it immediately. We also have another way to exit the current iteration of the loop, but still continue on with the remaining iterations. So I'm going to copy this entire loop that we have here, and we're going to leave it as is. We're going to leave the break here as well. We're also going to add another if, change this one to 5. And so if I is equal to 3, then we're going to continue. And so what continue will do, continue is going to stop the loop and then go on to the next iteration. So if there's code down here, so if we have code, we'll say console.log, this will be high. This high won't actually execute here. This logging, this isn't going to execute because as soon as continue is hit, we jump right up to here, increment I by 1, and then check our Boolean, and then continue on with the next iteration of the loop. It's sort of like break, except instead of exiting the entire loop, we just exit the single iteration that we're working on. So in this situation, it'll break at 5, so that we won't go any higher than 5. And when we get to 3, we're not going to log high. So we should see high only 4 times. We're going to execute this, add a little bit of space again. So we have 1, 2, 3 highs. And we don't have 4 highs, so I did say 4. It actually should be 3 highs because I forgot that we're breaking right here. So we do break right here, which immediately exits out of the loop and also doesn't print that out. So we see high 3 times. So with for loops, what we can do is we can iterate through the elements of an array. So if we create an array, I'm going to call it letters. This will be an array. We'll have A, B, and C. We can make it a for loop. So we'll start at 0 because arrays start at index 0. And as long as I is less than letters, we can use dot length. So remember with TypeScript, when we hit dot, we get everything available. So to access the total number of elements within the array, we use dot length. And then we just increment. And then we can print out everything within the array. We can do a console.log. We can access the array. And then we'll use index I, which is going to update on every iteration of the loop. That will print out A, B, and C. It's really important here that we use a less than instead of less than or equal to, because the letters.length is going to be 3 because we have 1, 2, 3 elements. But the indexes are 0, 1, and 2. So we do want to use this less than because if we have 3 as one of our indexes right here, then that's just going to crash. That's not going to be good. So we don't want that. So we'll save that. And at the end of our log here, we should see A, B, and C. And so right here at the end, we have A, B, and C. Now, this is not the recommended way to actually iterate through an array. We will be covering a more appropriate way in a few videos, but this way does work, and it is usable for at least for now until we get to more advanced concepts. And that'll do it for the for loop. I'll see you in the next one. In this demo, we're going to be taking a look at the while loop. We'll open up the demo folder, scroll down to repetition while, and open up repetition while.ts. So just like the for loop, a while loop is used to repeat code over and over. The main difference is the for loop automatically sets up the variable that we're checking and can do the incrementing, whereas the while loop only checks to see if we need to keep going. So we need to manually do the rest of the work that the for loop does automatically. So let's start with an example. We have I equals 1, and we have the keyword while. So while begins the loop. So while Boolean expression, so this one will be less than or equal to 5. So while I is less than or equal to 5, we're going to execute some code. So it does read a little bit better because you can kind of read it like English. So while something is true, then we're going to execute code. And so this is actually going to repeat forever. So if I was to run this, which I'm going to do, I just want to show it as an example. I'm going to run this. Maybe don't recommend running it on your machine, but on mine, there we go. It's just running forever and ever and ever. And if you're on Linux or Mac, you can Control-C to exit, and I think it's Control-Z or Control-D on Windows. So if you are stuck in an infinite loop, that's how you can exit. So we're checking this Boolean right here, but we're not actually changing the value of I within the loop. So in this case, we set I equal to 1, and I in 1 is less than 5, so this will be true. We execute code, and then go back to right here. It'll check again, and it'll still be true. And it's going to be true forever because I is just set right here and it doesn't update. So when we create while loops, we need to update the value within the loop. So if we just do I plus equals 1, then we should get the behavior as the same behavior we had in the previous video where we just print out 1 through 5. We'll just confirm that. And so now we have 1 through 5 printed, and now it's working because we're actually changing the value of I within the loop. Now, just like the for loop, the while loop can also break or continue. So if we copy this whole thing, we'll set I equal to 1. And if we just want to immediately stop, we could just break, and that's going to pop right out of the loop. Put a little bit of dashes there to indicate the difference between the two loops. So it's just going to print 1, and then we're done. So 1 and done. Now, we also can do continue. So if we want to continue, let's say we want to continue whenever I is equal to 4. We'll continue. We also need to remember to increment I. I'm going to increment I in here, and I'm also going to increment I right here. It actually should be before the continue. So I'm incrementing I twice, because what's going to happen if we don't do that, when we get to I equals to 4, right here, if we continue without having this here, if we continue, then I won't increment because our code is down here to increment I. So when I is equal to 4, we'll create an infinite loop. That's why we need to increment I here. That way when we continue, I will then be equal to 5, and we can go down here with the rest of our code. So let's hop into a terminal and we'll try this out. We'll run this again. And so now we have, we'll put a little separator there so we can read that better. Try that again. So now we have 1, 2, 3, and 5. And that's because we skipped 4, because we used continue. And while continue does skip the current iteration, it doesn't exit the entire loop. So again, break will exit the whole loop, and continue will just exit the current iteration and go on to the next one. Now, another thing we can do with while loops is create an infinite loop. So to make an infinite loop, we just do while true, because true is always true. So this is going to loop forever. Now, the thing with infinite loops is you're going to need to figure out some way to break out of the loop. And so in this case, I'm just going to use what we've been using with our I. So we have I. And so if I is greater than or equal to, let's say, 30, then we'll break. And we'll just make sure that we always increment I by 1 at least. And so when it breaks, we're going to log out of infinite loop. All right, so I'll run this, and hopefully that actually terminates. And so our infinite loop does exit, so that's good. So whenever we have an infinite loop, we always want to manually exit with a break at some point. So most of the time, it'd be a good idea to just use a for loop. That way we don't accidentally end up with infinite loops, or if we forget to increment or anything like that, because the for loop will do the increment for us automatically, which is usually what we want to do. However, the infinite loop is kind of the special case for while, where it's definitely easier to make an infinite loop with while than it is with for. And that's it for our video on the while loop. I'll see you in the next one. Organization is one of the most important aspects of writing code. To help with this, we can modularize our programs. For our organization efforts so far, we can organize logic into functions. We can put data into a variable. We have objects, which contain a collection of variables. And we also have arrays, which can contain multiple variables or multiple objects. These three things are great and enable us to build software. However, eventually we'll want to package all of these things into a single unit. This is where modules come in. A module allows us to take all of these things and group them into a single package. So if we want to access a function or a variable or anything else within the module, we just need to reach into the module and grab it. Just like functions and variables, modules have names. So when we want to pull something from the module, all we need to know is the name of the module, and we will gain access to the content within it. Unlike a shelf, modules don't have a size limit, and so it's technically possible to add as many things as you want to a module. However, this can become problematic because once a module starts getting large enough, it has a reduced organizational capacity just because it's hard to find what you're actually looking for. So instead of making one large module, try making multiple smaller modules. It's much easier to throw a box or two on a cart instead of needing to navigate a warehouse and use heavy machinery just to find the one thing you need for your program. Modules should also only have a single purpose and perform one or just a few related tasks. This helps keep them small and modular. Here's an example of some modules. We have data validation. All this module would do is make sure that some data is valid given a certain criteria. We can have a volume calculation module, and this module would only calculate the volumes of shapes and not do anything else. We can also have a discount application module, and this module would apply discounts to orders based on some business-specific criteria. Writing modules with a singular goal in mind helps keep them organized and much easier to work with. That's it for our high-level overview of modules. I'll see you in the next video where we'll start creating our own. In this demo, we're going to be taking a look at modules. So we'll open up the demo folder, scroll down to modules, and open up modules.ts. Now, before we start writing any code in modules.ts, we're going to right-click on the modules folder, make a new file, and name this one chord.ts. We're going to make another file, and this one will be named math.ts. So this chord and math are going to be modules that we're going to be using in our modules.ts file. So we'll start with the math.ts file. So in this math.ts file, we're going to be creating some functions and type aliases, and we're going to make those available in our modules.ts. So the first thing we'll do is just create a function. We'll use our handy addition function with the left-hand side and the right-hand side. So we'll return left-hand side plus right-hand side. Now, right now, this function is only available within this math.ts file. Make it available outside this file, we use the export keyword. So we're going to export this function out of this file. We can also do this for constants. So let's say we have pi by accessing the math.pi. And we want to export that. We can export that as well. And we can create a new type. Let's say we want to have int mean number. And we can also export that. So all of these will be available outside of this module. Let's hop on over to the chord.ts. We're going to export another type. So we'll export type point. It'll be x and y. So chord will be for coordinates. Right, so we can export that. And we're going to ignore this warning for right now because we haven't covered interfaces yet, but we will get to that point where we use interfaces, and we would want to change this from type to interface. But for now, we're just going to use type. So now we've created our modules. We've exported a type here from chord.ts, and we've exported a function, a constant, and another type from our math.ts. So now we're going to use these in our modules.ts. So we've been using this import strict as assert from assert, and this is importing a module for us. And we're going to be importing our own modules that we just made. So I'll start with importing our math functionality. So we're going to import, we need curly braces. We're going to import our add function, and we're going to import pi. And we use from /, and // will access the current path. So // is going to access this modules folder and everything within it. And if we type in // you'll see that we get a pop-up. So we have // and we get a pop-up of the available modules. Sorry. Yeah, so there's a pop-up with the modules. So we want to import from math. And we can do the same thing from coordinate. So we can import point from our chord.ts module. And so this is how we import things. We have the import keyword, curly braces, the names of the exported things that we want to import, the word from, and then the path to the module. So this assert package is built into Node, so we actually don't need to use a path. And if you use npm to install your packages, then you don't need to use a path. The path is only for your own project where you have access to the module directly right here. That's when you use the /. It's also possible to rename your imports. So if we look at our math module, we have this int right here as a type alias. Now let's say in my code, I don't want to use the word int, I want to use the word integer. To rename an import, we type in the name of the import that exists in the module, which is int. We use as integer, and that's going to rename it. So now we can use integer in our own code. We can have something like this. We can say that's an integer, and that's 3. And so this is just renaming what we already have. And that's useful sometimes if you have multiple things with the same name, or you want to use a shorter name or a longer name or more descriptive. Whichever name makes your code more clear is the name you should use. But for the most part, the default names that are part of modules are usually going to be just fine. So now that we've imported all these things, we're able to use them. We can use integer, we can use add, so if we want, or we can add 2 and 2, and that works just fine. And we can mouse over it, and we can see the function signature because it's imported properly from the math module. So there's the function signature, LHS, right-hand side returns number. And then we look at this one, and we have that LHS, right-hand side returns number. And the same thing goes for all of this. So now we can access all these things from math and all of these things from chord. So now there's one more thing I want to show you, and it's something that you're going to see a lot, but I think putting it into your own code is probably not the best thing to do, but I'm going to show it to you because you're just going to run into it so often. So if we go to our chord.ts, we can do a default export. Do a default export, we do export default point, and we're getting an error because I actually have the error turned on for doing default exports because I don't think it's that great of an idea to do. But for now, we're just going to ignore the error. So when we do export default, what that will allow us to do in our module, instead of using these curly braces, I'll comment this one out. Instead of the curly braces, we just import like that. And that's going to automatically import this point here. Now, the thing with default exports and importing them is this is actually renaming it. So we can name this whatever we want. We can name this coordinate, and this coordinate is still going to be a point. So it's giving us a type alias, and it's telling us that it's equals to x and y, which is what x and y right here. Now, I don't actually think this is a good thing to be doing, but like I mentioned, there's going to be a lot of JavaScript libraries that do this, and also a lot of TypeScript libraries that have the default exports. And it doesn't really add anything to have a default. It just makes things more confusing to use because now we have to rely on the documentation to actually get the correct thing to import, because we can name this that, and now that's still valid code because we just renamed the import. And if you don't have a default export, so if we just delete that or comment that out, so if we just have a regular export and we import like this, all we need to do is have the curly braces, and then we know the exact thing that we're importing from the other module. So that's just a little aside that I do want to tell you about, but like I mentioned, it's something that you shouldn't be putting in your own code, but you will see it a lot in other people's code. And that'll do it on the demo for modules. I'll see you in the next video. In this video, we're going to be applying some of the things we've learned so far by creating a small program. So to get started, we're going to open the app folder, grep folder, right-click, new file, grep.ts. So what the grep tool will do is it's going to open up a file, search through it, and it's going to search for a search string that's provided by the user. So we need some way to open files, and Node provides a module to do that for us. So we can import read file sync. That's going to be from the FS module. And the FS module is just short for file system. We also need to parse arguments. So let's take a quick look at a terminal. So when we execute this program, it'll look something like this, where we use our TS node, we have our grep.ts, and then we're going to have a file name, and then our search string. So these right here, these are called the arguments to the program, and we need to pull these arguments out into our code. That way we can read them and open the correct file and search for the correct string. So we're going to write the code to do that. So for this, we're going to create a constant called args. We can use the process module that's provided by Node. And we use the argv property. And the argv, that's going to be all the arguments passed to the program. Now, I actually just want to run the program now and print those arguments. That way we can see what we're working with, because it's going to include everything on the command line. And so we need to pick out the correct ones for our particular program. So if we actually run this, so we'll have file name and search string. So it looks like we're getting an array back because we have square brackets. And this is all the arguments that are on the command line as indicated by argv. So we have this thing right here, which is node modules ts node. So this is our ts node command. And then we have our rep.ts. So it looks like our arguments start here. So this is 0, 1, 2, and then 3. 0, 1, 2, and 3. So we don't care about this bin.js, and we don't care about grep.ts because that's just a program. We're concerned with the file name and search string, and those are in positions 2 and 3. So we need to pull out index 2 and 3 from the arguments in order to use them in our program. So we'll do that now. So to get those two, what we can do is take argv.slice, and what slice will do is it's going to cut the array up based on the parameters that we provide. So the first parameter, we're only going to use the first parameter. We're going to use 2, and that's going to jump straight right here. So we have 0, 1, 2, and 3. So it's going to jump straight into 2 and then cut the rest of this array off. So our array is just going to be our file name and our search string. Just to make our code a little bit more clear, what we can do is we can take our file name and we can use args0, we'll index into that. And then we have our search string. It's going to be args1. So even though our initial argv right here goes up to 3, when we slice it, the new array is going to just have 2 elements. It's going to have file name and search string. And so their indexes are going to be 0 and 1 instead of the one that's displayed. And let me show you the output of slice just so we can see that. So we'll have console.log and we'll have args. This is after slicing. So right there is before slicing. And here's after we slice. So we just cut these 2 out. And now our new 0 index is file name and our 1 index is search string. So now that we have that, what we can do is we can read the file. So we're going to have the file contents. We'll use our read file sync function that we imported. Read the file name. And then we're going to have UTF-8. Sorry about these pop-ups. So UTF-8, that's just the normal file encoding for standard files that are not binary files. So it won't work for images or anything like that. This will only work on text files. Once we read the contents, if we put our mouse over this, I'm not using any type annotations. So this is all just JavaScript. There's no actual TypeScript yet. But remember, TypeScript's still running behind the scenes. So if we mouse over these, it's telling us exactly what these are. So that's a string, that's a string. The contents get read into a string. And so TypeScript is checking things even though we're not actually pulling the TypeScript features into our code yet. The next thing we need to do is go and split this file into lines because we're going to search line by line. So we're going to create a new variable called lines. We'll take the contents and use the .split function. And the .split function is going to split it based on some character we provide or some string. So if we use \n, that's the code for a new line. So it's going to split the file based on line by line. So I want to run the code and I'm going to log the lines so we can make sure that it's actually splitting properly. So we'll run this and we'll run it with package.json and we should get a bunch of lines from that file. And so it is printing the lines. It is detecting each one properly. If we look at the file, we'll look at it in a minute, but we'll see we have the curly brace, name, version, license. And if we look at that file, we have curly brace, name, version, license. So we do know that it is splitting the lines properly. So now what we need to do, we actually need to go through those lines and look for the matching search string. To do that, we're going to use a loop. We'll use a for loop. So we'll be let I equal 0. We only want to loop up to the lines.length. And on each line, we're just going to increment I. We use if. So if our current line, lines I, if that includes, .includes will search the string for us. If it includes the search string, then what we'll do is we'll print it out. So we'll have console.log. That's going to be lines I. So we are getting a warning here. We can just safely ignore this because we haven't covered it yet, and we'll be covering that in a few more videos. But for now, we'll ignore it because it just wants us to use a more modern version of this loop, and we will be using modern versions almost exclusively later on in the course. But for now, we'll just use the old C-style loop. There's one more thing that I want to do is I want to remove this console.log, and that should do it for our program. So it's a pretty straightforward program. There's not much going on. I just wanted to keep it fairly straightforward since this is our first time putting all the concepts together. And now we can hop into a terminal and run this and see what happens. So what we can do is we can use pnpm-exec and we'll execute grep.ts. And now we need to enter the file that we want to search for. I actually want to search the source file that we just wrote. So I'm going to type in the path to our file and I'm going to search for the word consts because we made several constants. So we should get a listing of every line that has the word const in it. So I'm going to hit enter. And so there we go. So it searched our file and it pulled out every line that had the word const in it. So we had 1, 2, 3, 4, 5. And if we check our source code, we have 1, 2, 3, 4, 5. And it'll work for anything. So if we want to look for our console.logs, do that as well. So if we just search for our console, and see, now we have our console.log line. And that'll do it for our program. You may have noticed that this actually didn't really use TypeScript at all. And that's because we don't really have to in this case. If we mouse over this, we'll see that TypeScript is already kind of behind the scenes doing everything. So we don't need to actually introduce the TypeScript syntax and the annotations for this particular program. And this program is just a warm-up program to become more familiar with JavaScript. And in the next videos, we'll be making a slightly more complex application and then jumping into the more advanced TypeScript features. I'll see you there. In this video, we're going to be writing a slightly more advanced application. This is going to be a to-do application, which will allow us to save, load, list, add, and remove to-dos from a task list. So we'll get started by opening app, to-do, right-click, new file. We'll name this one todo.ts. So since we'll be working with files, we need to import fs again, like we did with the grep activity. We're going to use a default import, so it's going to be import fs from the fs module. We also need a path to save our actual to-dos. So this will be the file name that we saved our to-dos. So this will be to-dos path equals todos.json. We're going to be just saving it into a JSON file since that's already built into Node. So we're going to make a new type for our to-dos. So I'm going to call it type to-do, and it's going to have an ID number, and we'll have the task. And the task will be whatever is the actual to-do thing, the to-do item that needs to be done. A little bit of tongue twister there. So I'm going to write out our function signatures and then we'll fill them all in. So we need to be able to get to-dos. So we're going to return an array of to-dos. And we also are going to need to list out our to-dos. So we'll list them out. And that's not going to return anything. It's just going to print them on the terminal. We also need to save our to-dos. So to save them, we'll have to pass them into this function. That's not going to return anything. And then we're also going to remove to-do. And we also need to add a to-do. And the last function we're going to have is for handling the CLI. Our CLI is going to be a little bit more advanced than our grep one. It's going to be a command-driven CLI. All right, so we'll save all that. We're getting a lot of errors because we have to have function bodies, but we'll be adding those as we go. So we're going to start with saving to-dos. So enter the save to-dos function. And to save the to-dos, all we need to do is take our to-do array right here, our to-do array. And our to-do array is going to contain an array of to-dos, which has the ID and task. And this will get saved as JSON, just as is, as an object. So we can do that by just using fs.writeFileSync. And we're going to save it in our to-dos path. And we can use the json.stringify function, and that's built into JavaScript. So we have stringify to-dos, and that's just going to turn it into a JSON file, and it's going to save it. So that's all we need to do for that function. It's really straightforward. Next, we're going to we'll do add to-do. So for add to-dos, actually we're going to do get to-do, do get to-dos. So to get to-dos, we need to load the file. So first we're going to check to see if it exists. So we can use fs.existsync and check our to-dos path. And if it doesn't exist, we're just going to return nothing. So it's going to be an empty array, so there won't be any to-dos. If the file does exist, we're going to try reading it. We'll use read file sync, and we'll use the to-dos path. Then we'll use the json.parse function, because remember, we save our to-dos as a JSON file, so we need to parse it into actual data we can work with. So we're going to parse the data and use .toString to turn it into a string. And we're going to use a type assertion to say it's a to-do. So we can use as to-do, and that's going to force TypeScript to turn our parsed data into an array of to-dos. I know we haven't covered this as syntax yet. We'll be covering it in more detail in a future video. For now, just understand that it takes whatever is right here and forces TypeScript to interpret it as this data right here. Next, we're going to hop back down to our add to-do function. And the first thing we'll do is actually get the to-dos. We'll use our function we just wrote. We'll use our get to-dos function. And that's going to get our to-dos. So TypeScript does understand that we have an array of to-dos. I'm going to add a type annotation just so we can easily see that it is an array. Now, all of our to-dos have an ID number right here. And that's generated. We need to generate that when we add it. And so we're going to do that in this line. I'm going to use a ternary to do that. We're going to take the current length of the to-dos, and if it's greater than 0, meaning there exists some to-dos, we're going to have to make a decision. And so if there's more than 1, or if there's more than 0, we're going to index into the to-dos, and we'll get the last one, and we'll get the ID number from that. And that last one is always going to have the highest ID number. So it's going to be possible for the user to delete the to-do items out of order. But whenever we add a to-do, we're going to push it at the end. So the one at the end will always have the highest number. And so if we do it like this and we add 1, then that'll give it the highest number plus 1. And if there's no to-dos, then we'll just start at index 1. So once we have our ID, we can access our to-dos array, push it, and then we're going to push in the ID and the task. And the task is just a string. So we're pushing the same shape of an object. So we have our type of to-do is ID number, task string. And here we have an object with a curly braces, ID number, task string. So the types match. So that's why we're not getting any errors. Everything's good so far. Once we push the new task onto the to-dos, what we're going to do is save the to-dos. And we'll log a message. We'll use a template literal. This will be ID and task. So we finished up our add to do function, and in the next video, we're going to make our remove to do function. I'll see you there. In our last video, we finished up our add to do function, and in this video, we're going to continue and we'll jump into our remove to do function. So for our remove to do, what we're going to do is we're going to load our to-dos first with our get to-dos function. And then for removing it, we need to get the index of the to-do. So when we save these to-dos, we have the ID, and there's also the index. So the ID is what is a unique ID for each to-do right here as part of the object. And then the index is where it exists within the to-do array. So we're removing it based on the ID number because the user will have a list displayed and they'll have to pick the ID number to remove. So we need to map the IDs of the index. So for example, if we have IDs 3, 1, and 7, maybe those indexes are 1, 0, 1, and 2. We need to take, for example, ID 3 and find index 0. That way we can remove it from this to-do array. And that's what we're going to be doing. So to do this, we're going to create a constant named index. and we're going to access the to-dos array and use the find index function. What the find index function will do is we're going to give it a function to run, and it's going to run that function on every single to-do item. And whenever the return value is true, it's going to give us back the index of where that occurred. So we can actually pass functions into functions. We're going to be doing that. So the function takes a to-do, and we just need to return some kind of comparison. And all we need to compare is if our to-do ID is equal to the one that we're looking for. So if we mouse over to-do, that's actually a to-do object, which will have an ID in a task. So we're able to access the .id with the current to-do being looked at, compare it to the ID passed in by the user, and if it's true and equal, then we're going to get that index back and place it right here. And so if we put in 7, then we're going to get 2 back in this example here in the comment. So if we can't actually find the to-do, find index is going to return -1. So we need to check that. So if the index is not equal, we'll say if the index is equal to -1, then we're going to log a message. And it's going to say, could not find to-do with ID, then the ID number. And if it's not -1, just return early. If it's not -1, then we're going to remove the to-do from the to-do array. And to do that, we're going to create a new variable first. It's going to be called removed to-do. We're going to use the splice function. We're going to splice the to-dos array, and that gives us, we're going to start with the index. So if, for example, the index is 2, we're going to start at that index, take one item at that index, which is the one to-do we want to remove. That's going to make a new array. We're just going to take that first item in that array, which is going to be 0, and we're going to take that out. And the reason we're taking it out is because I actually want to log to the terminal the data that was removed. So we're going to log right now. Removed to-do. It's going to be removed to-do.id. And we're also going to have the data that was removed. That's just in case we accidentally removed the wrong one. The user is going to see exactly what was removed, and they can add it in again later if they remove the wrong to-do. Now, after we remove it, we want to save it. So we'll put save to-dos right here so we can save them. All right, and that'll do it for our remove to-do function. Next, we need to actually list the to-dos. So we can add and remove them, but we can't actually see them. So that's kind of important to be able to see those, so we actually know what's on our to-do list. So we're going to hop into our list to-do function, and we got to get the to-dos. So I'm just going to copy this line right here. We'll get our to-dos. And we're just going to iterate through them using a for loop. So we're going to let I equals 0. I is less than to-dos.length, and then I++. And then we're just going to log the information. So I'm going to log like this. We'll have to-dos I.id. They need that ID number so they can delete the to-do later if they want to. And we're going to have to-dos I again, access the to-do item. And we're just going to get the task, which is the information for the to-do. That's all we need to do for listing to-dos. Now it is giving us a warning because it wants us to use the new style loop. Like I mentioned in the previous video, when we use the C style loop, we are going to use the modern one in a little bit later, but I just want to use the C style one because that's still commonly used and it will work for everything. And there are little caveats with the modern loops that we haven't covered yet. So C style loop is fine for now. So now we finished up our functions here, and next we're going to be working on our CLI. Delete these comments, we don't need that. And we'll scroll down here, and we'll start working on our CLI function in the next video. It is going to be a little bit longer because the CLI actually it's command driven, so we have to add multiple checks here to make sure that the user gets proper feedback for each command that they want to run. So I'll see you in the next video. In this video, we're going to be finishing up our to-do application. We just finished the add, remove, listing, saving, and retrieving to-dos in the last few videos. And now we just need to be able to interface with it as a user. We're going to write the functionality for that right now. Now, the CLI is going to look a little bit something like this. So we're going to run the application. So we're going to have to-do, and then it'll be to-do.ts. And we're going to run different commands. So we're going to have, for example, add, and then this will be to-do item. And we're also going to have remove, and then we're going to have list. And so this could be commands such as that. So we're going to be coding those. So we're going to need the access to the argv. So we're going to have subcommand process.argv2. And I just want to log the process.argv again, like we did in the grep, so we can see which one we want to actually access. So we're going to log that real quick. So this will be list. Let me save that. Oh, we got to call this function. Let's call the CLI function, and now we can execute. So here's the argv for this program. Again, we have the bin.js, the todo.ts, so that's 0, 1, and the one that we're interested in is 2, and possibly 3, 4, 5, however many we want to work with. But the first one that we're concerned with is index 2, which is list. So that's why we're using 2 to get the subcommand. And we also are going to get options. So the subcommands may have additional options too. So we're going to use process.argv.slice, and we're going to slice 3. So that's going to start at index 3 and take everything after that. I'm going to use a switch for this. We're going to switch on the subcommand. So in the case of --help, we're going to display some help information. We're going to log to do add task. It's going to say add to do. Let's duplicate those lines. We're going to have done and then list. So done needs task ID. Let's put ID for short. This will be list to-dos. We'll just line this up. All right, looks okay. And we're going to break. We always break at the end of our cases. And so next we need a case for add. And we'll break. I'm just going to put empty code for all the commands that we're going to be doing. So we have add, we have done, and we have list. So we'll do add. So if our options.length is equal to 1, then we're going to add to do options 0. Where's options? Oh, this should be options with an S. And so the options is everything that comes after our subcommand. So for the add command, we look in a terminal. Our add command is going to look something like add, and this will be my task. And this thing here with the quotes, this will be the options. So even if we add additional things here, like if we keep adding stuff, well, this will be 0 and then 1, 2, 3, 4, because options is taking this whole thing and it gets spliced right here. So 0 for the options will be the actual task that we want to add. So if we jump back in our code, that's why we want to check the options right here. And that's why we want to get index 0. And we're checking the length equal to 1 because if they type more things like this, we don't actually have code to handle stuff that happens after this one. So we're going to assume that maybe they're trying to do something like perhaps some kind of special thing. So special option. We didn't add any code for that. So if it's not equal to 1, then we're just going to display some kind of error. And if it is equal to 1, which only has one item, then we're going to add that task. We'll have an else here. And this will just say invalid number of options. All right, and that's all we need to do for add, because we already have the function to add this to do. This is just the interface for it. Next, we're going to work on the done option. So I'm going to copy this block here, just the if else. I paste that down here into the done. So for done, we're going to check the options.length again. And if it is 1, then we need to get the ID. So the option for done is going to be the ID number. So we'll get the ID. We use parse int that's built into JavaScript. So we'll access the number, convert it into an integer. And if it's not a number, so if they type in like ABC, so if isnan, that's short for is not a number, we're going to log an error. We'll say option must be a number or subcommand done. And if it is a number, then we're going to remove to do. And then we'll change right here. This will change that to done. So we'll use the same error message. Next, we need to do the case for listing. So we're going to just copy options.length. We don't need the whole block, just that one line. So under lists, if options.length is equal to 0, because the list option doesn't have any additional parts, it should just say to do list, and then that's it, nothing else. So if that's equal to 0, then we're going to run our list to-dos. And if it's not, then again, we're going to have invalid number of options. I just copy one of them. I change that to lists. And then we're going to have a default as well. Let's say for the default, we're just going to log invalid subcommand. Right, so that should do it for our interface. Now I'm going to run this and see if it actually works. So we'll have lists. And so apparently I already have things. So let me remove my to-dos. Remove the to-dos. Might have been from some testing, but I don't have any to-dos right now. And I'm going to type in add. Let me get invalid number of options for subcommand. I'm going to type in --help, make sure we get some help message. So I'm going to add sample task. And we'll add another task. And now we'll list them out. We'll do a list. And so there we go. So now we have our list 1 and 2, and we're going to remove one. I believe we used done for that. So we'll finish task 1. And it says remove to do 1, and we'll list them again, make sure we can still see our tasks. And we'll also we're going to add again to make sure that we actually have the ID numbers incrementing properly. So this should give ID 3 because our current ID is 2. There we go. We have task ID 3, and we list them out, and we have 2 and 3. But I do want to do a little bit of minor code cleanup before we finish up. Now, we're doing a lot of this error logging, and we're retyping the same string over and over, so I'm going to extract that into its own function. So we're just going to make another quick function. We'll call it CLI invalid option. It's going to be void. And we'll have command. It's going to be a string. We're going to take one of these. We're just going to copy one of these, invalid number of options. Or copy that. Paste that in here. This will be invalid number of options for subcommand, and then we're going to have our subcommand. And we should probably be using console.error here instead of console.log. And we're just going to replace all the instances where we're logging this message with CLI invalid option function. This will be CLI invalid option. Command is add. Okay, delete that. And this is for done. And we keep scrolling down for lists. Same thing. This is for the list command. All right, and everything should still work. Also, just run one command, make sure everything's fine. And that should work now. All right, and so we're good. So just like the Grep application, this was just designed to be a warm-up for getting used to writing code in JavaScript. We haven't made too much use of the TypeScript features, except the annotations on the functions, like for example, right here. And like I mentioned in a few videos ago, these annotations on the functions are probably the most important thing and give you the most benefit over everything else in TypeScript. Now, we haven't even scratched the surface on what TypeScript is capable of. And in the next section, we're going to be diving into a lot of great things that TypeScript does to take your code to the next level and make it even more stable and reliable. But for now, even just taking like a plain JavaScript program like this and adding these annotations already is giving us benefits. Now, I didn't type anything incorrectly here with our program, but let's say you were just drawing some code together and we're working on this case right here where it's done. I'm going to comment this out. So let's say you're working on this part and your ideas are going like, oh, hey, we can type done and then number 10 and it'll work. And so the first thing you do is you just say, oh, okay, let's remove to do because I already have that function for that. And we'll take the argument here, option 0, and there we go, remove it. But as we can see, if we did this in JavaScript, we wouldn't get any errors, and that's fine. But since we did it in TypeScript, we're actually getting an error telling us that, hey, you're trying to use a string. Because if you're just going really quick, you might say, oh, there's a number 10. We throw the number 10 in here and we're good. But TypeScript catches that little minor error, and that's an indication to us that we need to write all this extra code. So even though we haven't even dived into the intermediate or advanced concepts of TypeScript, we're still getting the benefits of it right now with this simple program that's basically a JavaScript program with annotations. This finishes up our review section. In the next section, we're going to be covering more intermediate TypeScript, which will really take our applications to the next level and provide them with additional stability and code readability. However, if you're not comfortable with anything that we've discussed so far, make sure you go back to the exercises and try out the ones that you may not be fully comfortable with, because in the next section, you're going to want to have a pretty good understanding of everything we've covered so far. All right, I'll see you there.
Congrats, you've completed this crash course. Make sure to pat yourself on the back for this one. But don't stop now. Keep that momentum going and take your TypeScript skills to the next level with Jayson's complete TypeScript Bootcamp course, where you'll work on real-world projects and master advanced techniques that'll make you stand out as a TypeScript pro. By enrolling in Jayson's full bootcamp, you also get access to our exclusive Zero to Mastery community on Discord. Here you can get direct help from Jayson and other ZTM instructors, network with fellow students, alumni, and mentors. Watch the video on your screen to get a glimpse of our vibrant Discord community. One more thing, if you enjoyed this crash course, please help me show Jayson some love by dropping this video a like and leaving a comment with your questions, thoughts, or feedback down below. Alright, that's it from me, and I look forward to seeing you inside the Zero to Mastery Academy.